Hey, Amy. Hello. Um, yeah, I'll just take the minutes to get started. I'll be right back. Okay, hello everybody. Hello. Der Teufel. Hello, Real Enrico Palazzo. Sorry, I was mispronouncing it. TurboQ X2, hello. Hello everybody. Okay, so give me 5 minutes. We're gonna start the stream. Maybe, you know what? Maybe we can read another Google comic just to warm up the stream. Then we're gonna get into the main topic. I think we're getting close. Like application, I'm guessing in this chapter, this is basically gonna find a scheme, make us come up with a scheme so that we can write an application separately from the kernel. So like we write a user application that isn't just a function that the kernel written in the same file as the kernel that the kernel invokes. Then we're gonna do user mode. So we're gonna run that thing with limited privileges. And then we're going to implement system calls so that we can print from our user mode application. Yeah, and then there's disk IO. I'm not sure I want to do this. I'm thinking honestly of stopping a system call because I'm not super interested in the disk IO. There's a bunch of work and I attribute packed. Yeah, there's a bunch of work to do, and I don't know. I'm not super into it. It's probably interesting, but it's not what I'm interested in right now. Because the reason why I'm doing this work is just so that I can, just get some first-hand experience doing things, so that I can write smarter things in my Zig book. That's pretty much it. So yeah, I think I'm gonna skip these two. I'm gonna stop a system call. Yeah. So yesterday we had to do a lot of stuff. Well, more precisely, we had to fight the book a bunch because we were trying to go from shifts to packed structs, and some things were like just not coming together in the nicest of ways. Yep, not in the nicest of ways. Okay, so let's see. While we're warming up, what interesting news are out there? TikTok goes dark in the US. Oh no. So I remember where people were making fun of things not being available in Europe for one reason or another, right? Oh my God, Europe like this, Europe like that. Well, guess what happens also in the United States? Turns out even the land of the free sometimes has this stuff happen to it, huh? Making glow in the dark, strontium illuminate. That's fine. The Traitors, a reality TV show, offers a useful economics lesson. What? GitHub introduces sub-issues, issue types, and advanced search. What? Okay, so basically what people were doing previously, like in an informal way, it's now formalized. Like whenever there's like Git, the Zig Git repository has, well, in this case I should say the GitHub repository, since we're talking about issues specifically, has a bunch of issues where in the top level comment, a bunch of other issues are listed as like prerequisites. So yeah, I guess that's formalizing the same thing. Issue types. I don't love this one. Okay, this one, it's basically labels, but as a separate ontology, and you can have only one. Like nothing was gained pretty much. And now you have bug labels, and now you have also bug types. That one really not necessary, in my opinion. Bad idea. Find exactly what you're looking for with advanced search. Okay. Okay. So let's do some work. Interesting, this GitHub stuff. Like good, not so good. Yeah, cool, nice. Rust investigating an out of memory error. Okay, I'm slightly tempted. Where is it? Okay, there's a lot of context. Nah, I'm not gonna go on. Did you see this one? Is that how we think about Zig and Rust? The URL, man, is definitely something. That's for sure. Oh, I guess that's the date, 17. Yeah, that's the date. I get it. Yeah, I saw it. I think it's a good post. I think it makes sense. I think the perspective of looking at Rust as a higher level programming language than Zig is not a bad take. I don't know if that is, when it comes to all this stuff, every time you come up with like a way of looking at things, that is not necessarily the one true way of looking at things. There's always multiple ways of looking at things, multiple ways of, I don't know, what's the expression, slicing the pie. And maybe some could be more useful, maybe some others could be less useful, so they're not all equally valid. But at the same time, there is no one true definition for a thing. So that, with that being said, I do think that this is reasonable. Like looking at Rust as a higher form of higher level programming language that can more seamlessly transition into low level when you want it to. It's kind of the same thing that also Matt Clad was saying a while ago, and it seems to make sense to me. That's also another interesting perspective related to this is, for example, I was watching Toggle doing Ziglings the last couple of days, right? And Togglebit can create complex programs in Rust. He is designing a TUI library where the TUI layout is defined in a declarative way inside a config file that you can edit and reload at runtime, changing at runtime the layout of an application. So it's a way of letting basically users customize the layout of a TUI application to their liking at runtime. And so that is a serious application. There's a lot of bits and pieces involved, but at the same time, and he does know about pointers and stuff, but at the same time, some of the nuance, right, between capturing a pointer, dereferencing the pointer, copying the value, etc., when he was encountering this stuff in Zig, you could see that that was not the default way he was thinking about the code that he was writing. So he understands these concepts, but they are probably presented to him in Rust dressed in a different way. So he's probably not talking specifically in that way when thinking about what's going on in his application. But nevertheless, he can go really far, right, in a Rust application. So my guess is that this way of looking at Rust as a higher level programming language than Zig does make sense, because that's probably how Toggle has been using Rust when developing his stuff. In Zig, there is no way for you to write an application of that kind without being painfully aware exactly where everything is allocated, in which shape, what is a contiguous allocation, what is a separate allocation, what points to where. Like, you have to, like, that. These are the terminology, the concepts that you have to have in mind as you develop your application. So I think this is a reasonable take. Okay. Let's see. Let's see. Application. In this chapter, we'll prepare the first application executable to run our kernel. In the previous chapter, we implemented isolated virtual address spaces using the paging mechanism. Let's consider where to place the application in the address space. Create a new linker script user.ld that defines where to place the application in memory. Let's see, how does that want to go? Oh, we're going at 1. Instead of 8, we're going at 1, and then a bunch of zeros. So we're gonna have, there we're gonna load the machine code, read-only data with initial values, data that should be 0 field at startup. Okay. So let's do that. How many lines of code is early Linux? Is it possible to write an OS under 1,000 lines? So second question, I'm going to answer the second question first. So is it possible to write an OS in less than 1,000 lines? Yes, that's what this book is allowing you to do. Obviously, that's going to be an extremely minimal OS. We're not talking about an OS where, you have a desktop and you click around. And you know what? Maybe that could even be possible to pull off if you're super clever. I'm not sure. But in this case, what we're doing with this book is a actual OS, meaning you run an application in user mode and the OS provides it syscalls so that you can have, memory protection, that kind of stuff. And that is definitely less than 1,000 lines of code. As for early Linux, I have no idea. You can maybe go into the Linux GitHub repository and check out a super early commit, maybe the first commit. I don't know if Linux was started. Linux was probably started before Git, right? But I'm guessing they might have backported the history anyway. So you might still see in Git, in the Git history, well, commit by commit or close to. I have no idea. In any case, really no clue. I can tell you for sure that I guess if we want to have if you want to look at it at this question from a very practical perspective, the answer is that depending on how early you want to define early, Linux was 0, 1, 10, 15 lines of code, meaning Linux probably started looking something like what you do in this book, bit by bit. But if you're meaning like early Linux as in early but already having users, I'm guessing probably way more than 1,000 lines of code. If you think about it, when it comes to software, unless we're talking about JavaScript libraries, every time a project has users, it's more than 1,000 lines of code. Not as a hard rule, but that's pretty much the case most of the time. Again, unless it's a JavaScript library. If it's a JavaScript library, then things are weird and different. Okay, so we have our linker script. We have our stack, we have everything in there. Okay, so let's see. It looks pretty much the same as the kernel's linker script, isn't it? The key difference is the base address. Yep. So the application doesn't override the other stuff. Sure. Assert is an assertion. Yeah. So that if the thing is too big, then it complains. Yep. Okay. Userland memory. Next, let's create a library for userland programs. For simplicity, we'll start with a minimal feature set to start the application. Okay. So this is some kind of libc, I guess. I guess that's a libc, basically. It contains putchar, which is not even implemented. It contains exit that it's not even itself also is not really implemented. This one is just looping. Just looping. Attribute no return. Huh. Then we have start, which sets the stack. So puts the correct stack in SP, calls into main, and then once it's done calling into main, it calls exit. And I'm guessing main is not implemented here because it needs to go into what the user actually implements. So I don't know what do we need from here exactly. Because it's not going to be exactly the same as what we want to do with Zig. I think I may be wrong though. I might be wrong. You know what? I'm going to read a little bit more, see what it says next, and then decide if I want to commit in copying this verbatim or decide to do things differently. Let's see. The execution of the application starts from the start function. We know this because that's our entry point. So our executable will, we'll say the start is the entry point. Similar to the kernel's boot process, it sets up the stack pointer, calls the application's main function. We prepare the exit function to terminate the application. However, for now, we just loop forever. Yeah, fine. We define putchar that the printf function in command.c refers to. We'll implement this later. That's another thing that I didn't do. Unlike the kernel's initialization process, we don't clear the BSS section with zeros. This is because the kernel guarantees that it has already filled it with zeros, right? Because this is the memory that we get from the OS is going to be created with alloc pages. Okay. Allocated memory regions are already filled with zeros in typical operating systems too. Otherwise, the memory can contain sensitive information from other processes and it would lead to critical security issues. Yep. Lastly, prepare a header file for the userland library. Let's see, first application. It's time to create our first application. Unfortunately, we can't do anything. So the only thing we can do is loop forever in it. So that's what it does. So this is like hello world. Oh, they call it shell.c. I guess that's foreshadowing that this program will become like a simple shell, I guess, later on. And then we compile it. Okay, you know what? Let's start from shell. Let's then write the build script code to build our application. And then we use that to decide how we want to do with regards to start. Although I get it, like it does make sense that start is kind of something that you include in a sense. That's also what Zig does, basically. Although Zig, well, not exactly. Zig does provide start, for example, on Unix, on Linux, which is to be precise _start, and it's in the Zig standard library. I guess it's the Zig build process that orchestrates that for us. Well, in here, we're basically being what this is suggesting that we do. This is suggesting that we do this through the linker, basically. We create an object file that contains this snippet, and then these guys are going to be left, well, no, this guy is going to be left unresolved, because then we can link with it later on. Do we want to do it this way? I think that's how I am gonna do it. Here's how I'm gonna do it. I think I will implement start as part of my application. So I'm not gonna do with the libc. I'm not gonna go with the libc approach. The libc approach, I feel it's a C-ism that I don't want to replicate. So here's how I'm gonna do it. My application. So I'm gonna write shell.c or shell.zig, I guess. And in there, I'm going to have start. So let's see. We have exit, start. Let's, okay, we need stack top. So let's copy that from here. Okay, so we have stack top. Then we want to have start. So let's see, what do they do? Naked and section. Oof. Okay, so how do you specify a section? Did we do that already in somewhere in kernel? Did we specify the section of a function anywhere? No, we do specify alignment, but not section. Okay, this is going to be our first time having to specify the section of a function. Okay, so let's go do that. So still it's going to be like export function start. Is that any no return? No, it's just a void. And then we say call conv naked. Oh, I guess we don't export it. And then we do add export. Declaration start. And then the options are std built-in export options. I'm doing this so that I can just go to definition on it and see what's in there. So name start. Linkage, I guess strong is fine. Section we have to specify. Visibility, I guess default is fine. What are the options for visibility? Default hidden protected. Oh god. Okay. Section. What was that? .text .start. I'm confused. Wouldn't it go in there anyway? Oh, anyway. Expected comma after field. What are we talking about? Does it need to go inside comp time? Does it really need comp time? Yeah, it does. Okay. Do we do it like this, maybe? I think I like this. Okay, so we have our start function. Everything is in order. So this guy sets the stack and then calls main and then calls exit. So okay, let's do it like this for now. Let's do the ASM stuff. So ASM volatile mv sp stack top. Okay. Hello, Wooza. So we do this. Now, the reason why they are using... I guess they're doing two things here. One is they are calling main. They are calling main instead of... what's it called? Jump and link. So they're calling main without touching the stack, because we manage that manually. And they don't want to, I guess, needlessly like push a frame or like do extra logic that is not necessary. And then there's also the problem that main is a symbol that is not defined in here. So I guess we maybe want to do call. I guess I could do this. I could do this, but that is not call. That's jump and link, I believe. Actually, you know what? I believe. Why don't we look at a disassembly? Let's look at the disassembly to confirm what I think. So function main. So this is going to be our actual main function. Here's the nice thing. This can be if we do use this though, we can do, for example, catch errors and then do nothing. And that allows us to have this signature so that we can use try in here. That would be nice. So yeah, and that's while true. Oh, while true. Okay. And then there's also exit that apparently is defined the same way. Let's not worry about that for now. Okay, let's just do this. Let's set up the build and let's see what the disassembly looks like. So they're using object copy. Okay. So what are we doing here? Building the application. Let's create a new script, run.sh, to build the application. Why is it called run.sh if it builds an application instead of running it? Well, instead of building and then running it, I'm confused. Let's see. It's similar to the kernel. Compile C files and link them using user.ld. The first object copy invocation, set section flags, VSS, alloc, context, -o, binary, shell.elf, shell.bin. Okay. Converts the executable file in elf format to raw binary format. Raw binary is the actual content that will be expanded in memory from the base address. Right, because elf, the elf file format has a bunch of like tricks in it where you can, like elf can specify things that need to be done at load time. Like you have a huge array filled with zeros, then you don't need to have in the elf file all those 0 bytes in there, creating like, let's say that you need to, when loading this program in memory, you need to allocate a 4 GB arrays filled with zeros. Without, if elf, like in the .bin version, you would have actually 4 GB worth of zeros in there in the file on disk. While with elf, there's ways in which elf can say, yeah, and here you put you put 4 GB worth of zeros, but like it's said in a more concise way. Plus probably a ton of other stuff. Okay, so this is basically producing like an image that is like the same as what happens after downloading with ELF. So the OS can prepare the application in memory simply by copying the contents of the raw binary. Common OSs use formats like ELF, where memory contents and their mapping information are separate, but in this book, we'll use raw binary for simplicity. Yeah. The second object copy commands convert the raw binary execution image into a format that can be embedded in the C language. Dot O turns that into an object file. Let's take a look at what's inside using LLVM NM. The prefix binary is followed by the file name and then start, end, and size. These symbols indicate the beginning, end, and size of the execution image, respectively. In practice, they are used as follows. Okay, we're going pretty far. Let's back up. Let's do this. Okay, so first of all, we need to build this stuff. How do we do this? So I want run to actually be run for real. So this is for us, at the very least, this is for us something different. This is something like, first of all, like there's another executable, maybe exe we can rename, and instead of exe, it can be kernel. And then we make a program, shell, well, in this case, shell.elf, shell.zig, basically freestanding, avian on, blah, 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 blah. Where's the entry disabled because it's set in the linker script. So yes. Oh, that's user.ld. So we use user.ld as our linker script. And then we don't, so this is an artifact that we create, but we don't install this. Also, there's more stuff. So map, we were saying we don't do. This is adding in there all the weirdo stuff in the way they implemented it, which we don't do. So we're gonna ignore this. Then object copy with some flags, and then object copy again. So here's the interesting thing. Yeah, this is not our final output. So if that was our final output, we would install it in the output directory. We say, okay, this artifact is what we want. Also, this needs to change. But that is not the case. That is not the case. In our case, shell is an intermediate artifact. Then we need to run more stuff on it. So we invoke object copy. Were we doing that already somewhere? Run cmd. What's run cmd? No, this runs qemu. You know what? Maybe we should move this to the bottom. Yeah. Okay, shell. I want to do this const object copy. So we have two invocations. So how do we do it? We need to give them a good name. Let's call it elf to bean. b.add system command. Okay, we want to invoke LVM object copy. Then what do we say? Well, we say all of this. You link the shell into the kernel later, though. Do we? Yes. You're right. So that means that we probably need to move this above the kernel. Actually, not really. I mean, it's up to us. This is all declarative. So I believe we can link against it. Like we can add a line that where we link against it later on. In any case, we'll see once we get there. So this argument. Oh, there we go. Well, you know what? I'll make them strings, but then we're gonna change those. Okay, so this is the full invocation, object copy, flags, blah, 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 O binary. And then there's the input file and output file name, right? So these last two things we want to do differently. So here's how we do it. We do, instead of hard coding them, because we don't want to put them in our install folders. We don't want to like put a bunch of garbage around. We want to keep these files in the Zig cache directory managed by Zig. We just want to know how to refer to them, which we can. It's super easy. So we do elf to bin. So we basically comment those out, and now we're going to provide them. We're going to append those command line arguments with a couple more function calls. So that is going to be add what is it? Artifact arg, I believe. Yep. The artifact in our case is going to be shell. And then, so this is the input, and this is the output file name. And then, so we do elf const bin equals elf to bin dot add output arg, output file arg, output file arg. Well, basically it's gonna be like shell.bin, but Zig is gonna prefix this with a path inside the Zig cache, so that this also this output file also gets put inside the cache, not in random places in our thing. And then bin is basically, it's a lazy path. Bin is a we don't know yet exactly what that path is gonna look like, but once everything gets resolved, we know that this is a path that can be passed around to other commands, for example, and which is basically what's going to happen here. Here we need to pass this to also on a second invocation of object copy. So you'll see now in a second how this is going to look like. So we have elf to bin, and now we do, what is it? Bin to const bin to O, I guess. So we invoke object copy again, and these are the arguments this time. Okay, same situation. This is going to be the input, and this is going to be the output. So we basically do it again. So here, this is bin2o. The artifact that we want to pass in is the bin file. This is this guy. This is the last one that we need to replace. And that's going to be, I guess, obj file, obj, or maybe shell obj. Okay, shell object, and .o, that's going to be the name they want to give it to it. Bin2o. Okay, so now this also gets put in the cache, and then this finally gets linked for creating the kernel. Okay. Zig build system object copy, see if it works well enough. How do you even access that? I don't think, do you even have this on 0.13? I think it would be worth having a stream where we try to upgrade to 0.14 and see what we can improve by upgrading to 0.14. But I don't know what, add object copy. Okay. Let's see. Base name, format, only section, pad 2, compress debug, strip. extract a separate file. Put the stripped out debug sections in a separate file. Note, the base name is baked into the alpha file, specify the link, blah, blah, blah. Okay, so that would mean like row format, bin hex elf. So that would be maybe the first invocation, then. So the first invocation would be set bin. What about the second invocation though? That goes from bin to object file. What's that, hex? I guess we can look at what make does. Are you using Z? No, I'm using Helix. I don't think we have the equivalent of the second one. Yep. So not today. Okay, so we have the shell object, and then we want to do kernel add, I don't know, object file. Beautiful. So we're literally, by doing this, we're literally doing this. We're adding this guy in there. Okay, let's see how that goes. Zig build. Except that bitstep compile found lazy path. Oh, right. So this is not artifact art. This is add. Actually, I'm not sure. Just file arg, right? Because it's a lazy path. Okay, next. Runtime call not allowed in naked function. That's unfortunate. So I was asking originally if we could do that, right? I was trying to see if that was something that we were allowed to do, but we're not allowed to do this in a naked function. Okay, so we have to resort to assembly. So that it means that we need to do this. Okay, let's call it cmain. And here we do this. And we export this. To be honest, why does it matter for this function to have a naked calling convention? I guess it matters because it's gonna try to ret, and we don't want this to ret. We want this to do something else. But you know what? Out of curiosity, what if we don't make this naked? Because for now, this doesn't matter. We're gonna loop forever. Let's see. Let's wait for bad things to happen once we stop looping forever. As long as we loop forever, I think nothing matters. Let's see. Unable to export type function void. Right. So I can, I guess, export. No, I can't export. Unexpected token. Comma. Oof. Linker problems. Let's see. Cannot link object files with different floating point ABI. Right. With different floating point ABI. Okay. Right, because this object copy invocation has some funky float point stuff defined. Where is it? Build.zig. Yeah. Where is it? Elf. Wait, elf32. Okay, that's the output. Dash little risk v. Is that elf32 or is that elf32? Let's see. A bit unrelated, but do you know if any breaking changes that will happen to Zig after 0.14 ships? You mean breaking changes that are not part of 0.14, but breaking changes that come after 0.14, like for 0.15, that are not in 0.14? That is the question. Probably using namespace. That's the only one I can think of. Plus, I guess, standard churn in the standard library. But language-wise, I would say using namespace. Okay, so we have floating point stuff happening differently. We have probably different defaults somewhere. Okay, so why are we ending up with different floating point ABIs? That is annoying because the reality is that that's actually not really true. I think the problem is in this specifier. Let's see, object copy output formats. Oh, this one is not the LLVM one though. There's no way this guy is going to tell me what are the possible values. Oh, instead it does. Let's fucking go. So it does seem that this is really help Elf. Little risk V. That does not seem to be the problem there. Let's see if anywhere we see float. Of course, float is not mentioned any freaking where. Why would it, right? Why would it? Is there anything in the previous invocation? Set section flags, BSS, -O binary. So this guy seems fine. Honestly, this guy also seems fine. Cannot link project files with different floating point ABI. Right. So, okay, floating point behavior goes into the last part of the triplet, right? Risk V 32 dash freestanding dash Linux dash whatever, and then the third part is the ABI. Okay, you know what? Let's look at the options here. There is some mention of things. Default. Maybe we just need to say non hard float on new ABI. Yeah. Maybe this needs to be specified in here. No, but it doesn't accept a third thing. It doesn't accept an ABI thing, it seems. There's not even a mention of ABI in here. And we do compile it with ABI in .none. So, okay, out of curiosity, let's try this. Object copy error, invalid output format, -none is not recognized. Okay. I guess maybe we should try to inspect this guy and see what it says. Is there like an object file inspector? Is that, what does nm do? Like, what even is the name of nm? What's nm? Symbol table dumper. Why is it nm then? God damn it. So this gives you information. Okay, so this only gives you information about symbols. Do we care about that? No, we don't. We care about some metadata in the object file. So objdump, what does objdump have as options? Because we don't want the disassembly. We want something else. Object file dumper. This seems the right tool for the job. Adjust VMA. All headers. Display all available header information, relocation entries in the symbol table. All headers seems good. Archive headers, debug, demangle, disassemble zeros, disassemble this, dwarf, dynamic reload, dynamic sims, file headers, help, macro, specific attributes, mCPU, CPU name, target, a specific CPU type, mCPU equals help for details. So these guys seem candidates. No this, not that, offloading prefix, private headers. Okay, I'll do all headers, and then maybe we can take a look at this mCPU stuff. This mCPU stuff seems very very connected to what we care about. Architecture RISC v32. File format ELF32 little RISC v. Sections. Symbol table. Let's do mCPU. Help. Name mangling. Oh. I did mCPU help, and this is not giving me a ton of details, to be honest. Wait, is it because it needs to be before? Oh, it needs to be before, isn't it? Doesn't it? No. Yes. Maybe. Target specific CPU type. I don't even understand what that means. Target specific attributes. Like, what does that mean? Shouldn't this thing be specified in the... I'm not compiling. What are you talking about? Okay. It's time to ask somebody who knows a lot of this stuff. Let's ask Claude. Okay, how can Claude help you? In a build process, I'm creating an object file by using LVM obj copy. with this invocation. I'll copy that one from the book. So let's see. The problem occurs because when LVM creates a binary object file from scratch using LVI binary, it has to make assumptions about the ABI and other alpha flags, which may not match the original invocation compilation settings. Okay. You can use readelf to examine the elf headers and flags. Oh, that's interesting. We can access the elf files. So if we do zig build -- verbose, we're gonna see also where the elf stuff is. So we're gonna see that elf. Where's my elf stuff? Mm-hmm. Maybe we don't. Oh, you know what? It's because of caching, maybe. I think the problem is caching. Let's try again. Or maybe I'm wrong. No, I'm not wrong. It's this guy. There we go. I don't have read elf. Oh. G objdump otool -l G read elf. Okay. Brew moment. Jesus, it's huge. It's interesting though that the docs for object copy, they don't mention any of this stuff. Elf specific options. I don't have gread elf. I don't have read elf. I don't have any of this stuff. Wait, we notice it's keg only, which means it's not sim linked. Oh, because it shows us the host toolchain. Okay. Can I do where? No, not where. Brew. There's a command from brew. Oh, of course they don't even show it here. God damn it. I guess I can do this. Okay, we finally have gread elf. Jesus Christ. We just cannot do it in here though because we need a new thing. So I'm just gonna copy it and run it in a different shell. Where's my elf file? I lost it. Shell.bin. Shell.elf. There we go. You can use LVM read elf. Oh, wait, do I have that? I didn't even know that was a thing. God damn it. Wait, it doesn't even say anything. Read elf. Okay, so let's go back to this guy. Oh fuck, I didn't read this part. I should have read this, huh? -H. God damn it, I should have read that part. Okay, class elf32. Data, 2 components, little endian. 2's complements, sorry, little endian. Version 1. Current. Unix SMV ABI version 0. Machine risk V. Double float ABI. There we go. Flags. Then if we look instead at do I have Zig out? Fuck, I don't have Zig out. Okay, temporarily, let me not link against this. So let's not do this. So this is now going to build the kernel without any without our programs. So I can do read elf-h on zig out bin kernel.elf, and that matches. So all of these tracks, and I bet you that it doesn't track anymore. for this version. Well, oh no, wait, for the bean version, not this one, but it's before as we were building this stuff, but this guy. So for this guy, this doesn't match anymore. Is that it? Let's see, still read alf. Can we do the same with read alf? To fix this, you can specify the ABA flags when creating an object file. Try adding these flags to your object copy command. Wait, what is it actually adding? So this is doing section alignment. None of that seems particularly interesting. None of this seems relevant to our problem. The problem is that that's not on. Can I run read elf on an object file? Oh, no, because this is a binary file. It's a bin file, right? So I guess this guy doesn't have. Okay, I think I get it. So the bin file doesn't have any metadata assigned to it. That's the problem. So the problem is actually okay. The problem is here. Then it's this guy. Yep. Oh no! Look at this. That's it. Set flags 0x5. What is the LED icon on your dock? LED? Lead? I'm not sure which one you mean. Leaf. Lorien. It's like it's a drawing application. Okay, so set flags 0x5. And we do that in this invocation, right? Okay, let's see how that goes. Unknown argument set flags 0x5. Wait, isn't that an invocation to object copy? iBinary. Yeah. Oh, it's a space. Lorien. You can see it here. Unknown argument set flags. Oh no. Why are we getting memed by object copy? set section flags. It only has set section flags. It doesn't have set flags. So I guess we got memed by the LLM because there is no set flags. Man, that sounds so good, but I don't understand why they're going through a row binary as an intermediate step. Because the way I understand it is so that if there's anything clever in the elf file, it gets first like expanded into the final image, right? That's what I'm assuming. Oh god, now it's suggesting more garbage ideas. Elf edit. This is a huge rabbit hole. I'm honestly disappointed by what's going on here. So the problem is that even if we try to use the built-in object copy that Zig has, it still won't have that. Okay, so here's another thing that we can do. Maybe we can change the floating point ABI on our end, meaning we can remove that flag in our elf file so that we can conform those two things. At the end of the day, we don't care about the floating point ABI, right? The problem is that none of these values really matches nicely to what we care about. There's an extra syntax though, right? That we can use to specify features, like toggle them on or off. I don't remember the details, but it can be done, right? CPU model features, right? Right here, there we go, feature set. Jesus Christ. Although I don't remember the details, like how do you like remove double floating point support from the feature set? Hmm. Preferred alignment. Float ABI. Okay, that is so annoying. I think this is the kind of stuff that Jacob Lee would be able to solve in a moment, but I don't. I got banned from the Zig IRC because I made an LLM rewrite my notes into perfect English and some guy had a problem. So I shared my note for the problem. They banned me for saying something in LLM. Huh. Hmm. I guess the problem with this situation is that it's hard to know if you had the LLM just rewrite it or the LLM came up with it itself. So you want to know something funny about LLMs? Talking about rewrites, I spotted this recently. Am I logged in? I am. Can I send links into chat? Sure. Good links, please, not bad links. Lists? No. How do I? Is it in under Explore? Probably, right? Hashtags. URL. What? If I search for Zig Lang. Okay, wait. I think I need to find it on my phone. Or was it Blue Sky? Oh no, it's from Blue Sky. Right. Let's see. Let's go to Blue Sky. Am I logged in? I'm not. Okay, give me a sec because I don't remember my password. Okay, we're good. So where did I see this? I think it was under, no, not feeds, Ziglang. This one, this is hilarious. So this logo that you see here is the logo that I have on my personal blog. And they made a quote unquote news article related to Zig that talks about calm time. For some reason has my blog's logo in there. And then if you read it, it's actually an LLM rephrasing my blog post on comp time that I wrote a while ago in a weird and like not really fully coherent way. And then they also copied the image because they didn't like the image kind of tricked them into thinking that that's actually a Zig image while it's not a Zig image. What a weird thing to do. It's like, what a thing. Good job, people. Like I'm gonna do a lot of business with you. That's cool. Anyway. Okay, the blog post that you're linking has that doesn't seem super related with what we're dealing with right now. So basically, there are some CPU features that we enable in here that we would like to not have enabled. I think that if you have a like triplet string, you can specify this stuff more easily. Man. Okay, let's see what's in a query. CPU features sub. I guess that's kind of what we want. I guess I start from empty and then I add something to it. So I start from this guy. And then I add a feature. And it wants an index. Oh, Jesus. But I don't know how to use this stuff, though. So you see how there's... Okay, you know what? Let's put this into less. Oh, then it wants an index also. Oh my God. Yeah, Jigably is also a core team member of Zig, and he's doing a ton of work. And he also was he helped me out like the first day that I was trying to do this stuff, and like he knew how to do, you know, all the gnarly little things very well. So now I'm probably running in circles trying to do this stuff. Also because it's like, let's say that one of these things is a feature. I should probably try to understand the structure of these JSON file. But even then, like, also there's an F. There's no like stuff like double float. I don't get it. You know what we would want? I think what we really would want is to just edit that other freaking elf file to have those flags enabled. That is I think that is the shortest path. it's unthinkable to me that there is no easy way. I guess we could probably try to open the file and like just you know what? Maybe that's what we should do. Just flip a byte in the output file and call it a day. Honestly. Maybe that's another way. How do you join Zig and mobile experience and they want to make Zig a better C++ too and like have macros to it? I guess because macros are very useful, Rudy. So I'll give you the serious answer first, and then I'll give you the joke answer second. The serious answer is to become a core team member, you need to get involved with the Zig project, which means you start reading issues on GitHub. You get acquainted maybe also with PRs a little bit, and then you start contributing good quality PRs. Initially, your PRs don't have to immediately be perfect, obviously, although there's a lot of like contention of resources around PRs. So it's not super easy to get your PR merged right now if it's not a, super high quality PR. So being aware of the limits of the current situation, like the resource constraints, where the resource in this case is maintainers' attention and effort. If you contribute positively for a while and you also get involved, there's a Zig development Zulip. If you look at the communities page and you scroll to the bottom, there's also Zulip where a lot of the development happens, development discussion happens. You participate in discussions and you show that you're knowledgeable and your general ideas around what Zig should do are in line with what the project already wants to do, which you could say what Andrew wants to do, which is, I guess, a bit of an oversimplification, but I guess that's one way of looking at it. So if you are in line with where Zig is going, then and you provide good code, then over time you will become a core team member. There's somebody who recently just became a core team member, but it takes a moment. Now here's for the less serious answer. If you do like macros and you think that Zig would be a better language with macros in it, chances are that you're not going to become a core team member. Let me tell you, the stance of the Zig project and community in general and like ecosystem is extremely against macros. We have comp time. Comp time is all the metaprogramming you need. Fuck macros. But that last comment comes from me specifically. I don't know if other people are as against macros as I am, but in general, no macros, sorry. The flag offset is a 32-bit integer at file offset 0x24. So just edit that byte from 0 to 5, right? What do people use for editing a file that way? Like as a command line invocation one-liner, xxd or something? I don't know the syntax. Do I have xxd actually? I do. I mean, you know what? Sometimes I do make slightly inappropriate comments also. I don't know. So this is a funny thing. So on one end, I understand that when somebody covers a public position, then you need to be careful about what you say to some degree. You need to keep some kind of like propriety, I guess, to your actions. I'll make an extreme examples, right? You're the head of police. You should be, every time you speak in public, you should be stating that your point is to, pursue justice, make sure that people who are not guilty don't end up in jail. If you say something different than that, that is a problem, right? If you're the head of police and you say, I don't know, I'm easy to bribe, or you say, whatever, whoever stands in my path ends up in jail, I don't care whether they've done something bad or not. Those are bad things to say. At the same time, people, cover less important positions in like organizations, and sometimes other people expect them to become drones and not be humans anymore. So especially when it's somebody they don't like. So for example, if I make a spicy comment on Twitter, the people who don't like the spicy comment, the way they express their disappointment is not in your is a bad opinion, because I mean, they didn't just say I disagree. They say you shouldn't be saying this in your position, where in my case my position is VP of Community Disease Software Foundation. And I don't know. In any case, fuck macros. That's my statement. You decide how official you want to consider it. Though they have their benefits too. I'm sure that if you're trying to do so, here's where I see the benefits, right? You're trying to make a DSL of some kind. Maybe that's not the only one, but like a big one would be you're trying to make a DSL, and macros let you write a DSL. You want to make a DSL in Zig. Zig will fight you every step of the way as you try to make a DSL. And that's good in my opinion. Not because I think that DSLs are universally bad, not at all, but it is nice to have one tool that prevents you from making DSLs, not because it's not expressive at all. Like you can't make DSLs in C either, but that's because C is like not expressive much. You just can't do stuff. Oh right, it's DD, the tool for editing. Thank you. I'm gonna check it out now. Or you know what? Let's ask chat. Let's ask Claude. So I think Claude is gonna. Here's my idea. Use DD to edit the to edit shell.bean.o to turn on those flags. To turn on those flags, I guess. Can you give me an invocation of DD that does that? Well, I think we got it. I think commenting negatively on language features should upset anyone more than if anyone said it. I think shitting on an entire language is a little too far. I need an opinion that is what is official community or place where Zig people come and discuss? Yeah, no official place. So you can have, there is, I guess, one blessed community for development, which is the Zulip community, but that one is not a general purpose community. That one is just compiler developer people, like core team members, and well, not only core team members, but well, core team members and other people who contribute to the Z compiler, who go there and talk about how to contribute to the Z compiler. So that is not a general purpose community. There's a big community of Zig users on Discord, for example, that probably is the biggest community that I know of. That one is not official though. Zigit also is a pretty big community. It's a nice one. Like I would recommend Zigit as a community to join. It's not bad. But yeah, there's no official. Why print f pipe dd? I hate this style of things. Is there a way to invoke dd without the print f piping in front of it? You can use the direct. Man, this is going insane. Okay, so we went from this to this. Input file, output file. I think this guy is going insane. Okay, I'll take a look at Stack Overflow. So data from std in. Make a binary temp file with data to be patched. Oh, maybe that's it then. So the idea is that to create a file with that patch. That is terrible. So like we just create a file that has the value 5. So I guess we can do this. So print this into a file. Okay. So then we go into our build script and we invoke of to bin to object file, and then we do what's the full command? It's basically this, but we also need if. Problem is, I guess we're going to move that for last so that we can pass in a path in a semantic way. What am I doing weird? Wait, why doesn't the training comma make everything go down? Oh, it's because of this, right? Wait, what? Okay. Oh, by the way, you know what? I haven't been watching YouTube comments. Sorry, everybody. I always keep forgetting. I should add them to work. You know what? I'm going to add them to work eventually. Sooner than later. Yeah, I think people on YouTube are doing fine. Cool. So, yeah, we're looking at this. So we move IF last, and then we do patch. And then we do patch dot add file arg b dot path source slash hey toggle source slash man, you have no idea which kinds of curse things I'm going through. Source slash what was that? Alf.patch. So that's our input file. And then even though, so previously, here's what was happening. Previously, we were generating the shell object file, and then we were saying that the kernel depended on that. So the problem is that if I do this, if we do this, here's what happens. Kernel.add.object file only depends on this step right now. It only depends on us calling LLVM object copy to generate an object file. It doesn't depend on us patching that object file. So according to the build system, there is no dependency between these things. So like basically it means that the Zig build system as it is currently written is allowed to run this patching and this other compilation in parallel. The problem is that in our case, given our semantics, what we care about, we need also to wait for this to be done before we can run this. So here's how we make it work. I guess a cleaner way of making this work would be that instead of editing the file in place, we instead like make a modified copy, and then we depend on the modified copy. That would be a clean way. Another way is to explicitly say, look, you are not gonna allowed to run the kernel stuff until this patching is done. And the patching, and also, wait a second, also OF, also OF is in need of stuff. So wait, I also need to wire in this, and so that we know that this has to wait for this to be done. So wait a second. How am I gonna do this? I guess like this. Kinda. Okay, so this way now, this command depends on computing this guy. And now let's make the kernel depend on that. So kernel dot depends, kernel dot, wait, is it kernel dot step? Is it kernel dot depends on? Oh no, I'm gonna need some help. Wait a second. Wait a second. I feel silly because I know this stuff normally. This is already a step, so that's why we can do. Oh, because it's not with an S. It's just depend on. God damn it. Okay. Depend on, and then so we say that the kernel step depends on patching. So depends on running patch. So with this line, we're saying patch dot step pointer of Okay, so with this, we're saying, look, you're not going to allow to run the kernel build, which expects to link against our object file until we're done patching the object file. Okay, let's watch it fail. Oh, and I still have set flags that needs to be removed. If only that thing was true and real. Failure. Okay, let's see. No value specified for if. Oh, fuck. Okay, I get it. Shit. Here's what's happening. Look at what's happening. Look at our invocation. You see the problem? There's a space. No, dude. Why are you like this? Why are you like this? Can we do it without the equal sign? Will it be happy if we don't put the equal sign? Please. Unknown operand if. No, it wants it like this. Oh, but we have the solution. Let's see. Append an input file to the command line argument prepended with a string. So add prefixed file arg. That's our solution. Oof. Good thing that the Zig build system has thought of everything. Add prefixed. So that means that we don't put that there. We don't put that there. Let's see what the signature is. We have succeeded. Toggle, you haven't been here, or I don't know, maybe you were lurking, but if you turned on the stream when you sent the message, we've been here for a while trying to figure this one out. So the problem is this. The book, by the way, the book that I'm following for making an OS, it's not a Zig book. When I told you about this book and you showed me like a Rust equivalent, I forgot to point out that, yeah, this is not a Zig thing. This is a C thing. Every code sample in here, it's C. I'm just translating it to Zig. And so they use also C toolchains, and they do all kinds of weird stuff that then anything more disciplined just makes fail. So for example, here, what's happening is that we're taking an elf file. So that's like a normal Linux style binary. We are turning it into a raw binary file. And the reason why we're doing this is because elf has some, like an elf file doesn't just have binary data. It has some binary data, but it also has like commands and metadata. And some commands tell basically, here's one example that is relevant. Let's say that you have an array filled with 1,000 ones. In elf, what the elf format can say is place at this location this value times 1,000. And so that means that the elf file then, when it gets loaded into memory, will be different, because some things will be copied verbatim, like some binary data will be copied verbatim, but that this thing, for example, will get expanded to an actual 1,000 times 1, like 1,000 bytes worth of ones. And the reason why this is done by elf is because, well, without this, that means that the 1,000 ones would have to be in the file executable. So like every time you basically specify a big chunk of memory, even though it's all super repetitive, it would have to be verbatim in there. So since we don't have in our OS a elf loader, we don't go through the process of implementing like parsing elf and loading everything into memory. Also because this stuff is super complicated. What the book is making us do is, well, yes, you have your compiler produce an elf file, and then we use LLM object copy to basically turn that elf file into what it would look like once loaded into memory. And we save that as a bin file. And then it turns that bin file into an object file. So it adds some surrounding metadata so that you can link against it. And you can basically, this is like a complicated way, well, not complicated, but like this is a few steps way of basically bundling the binary of your user program into the same executable as the kernel so that you can basically more easily load it into QEMU. The problem is that apparently doing this process loses some metadata because there are some flags in terms of like CPU floating point support that gets lost along the way. And like I was asking Claude to help me figure it out. Claude understood the problem and was able to explain it to me. But apparently object copy, like LLVM object copy, doesn't have a way of overriding that value. And so we ended up saying, you know what, let's just override the bytes inside the header file where this information is stored using DD. Yeah, and so it seems to be almost working. So let's take a look at this assembly maybe over executable and see maybe what's in there. So we have boot, we have process A, we have write function, we have yield, we have process B, we have kernel main. Okay. Kernel entry, create process, kernel panic, context switch, unlock pages, write all. Oh no, this is like all the writer stuff. There's a bunch of spam because of printing and formatting. Yeah. Write bytes and times. Yeah, there's gonna be a bunch of that. Outline function 0. Yeah, I think this is all still printing. Like printing has a bunch of comp time that turns into a bunch of anonymous functions. Mem set, mem copy. Wait, where's my stuff? Wait a second. LLVM, NM, kernel alf. Wait, there's is that risky? Yeah, that's risky. How do I get just section names? Just want to see the sections names. Where is it? Oh, maybe this is the wrong tool. Because this is about symbols, right? Although, you know what? Let's see if we have in here, what do we expect to see in here? We expect to see main, right? Something called main. Oh, right. Kernel underscore main versus kernel dot main. I forgot, because the problem is our kernel main function is called kernel underscore main, but our user, our shell is just called main. You know what? Maybe let's call it shell. Although this is not exported, so it might not show up as a symbol. Yeah, it doesn't show up as a symbol. Okay, that's fine. Okay, so it seems that we succeeded in doing this part. Let's continue because right now we can't yet see that we fully succeeded. We only can see some things. So let's say shell bean.o has binary shell bean start, binary shell bean end, and binary shell bean size. Actually, we can check if this stuff is inside our final executable because they're checking on the temporary object file, like the intermediate thing. But let's see if it's also in the final one. So nm kernel elf, and then we do what was it? Shell? Yeah. Shell bean size. Binary users Christoph. Oh no, what is this thing? It's appending the file path. into the symbol name. Dude, why are you like this? No, we're getting memed by this compilation process. Oh no. Okay, Zig build verbose. Let's look at this. Oh no. No, dude. Why are you like this? So the reason why this is so complicated is because in pil.zig, it's an artifact of object copy. I think of this one. And this is horrible because not only is it like doing a bunch of stuff, but it's also truncating. Like this is taking the original path of something and truncating it. What a nightmare. So can we tell to object copy, please, like don't mangle stuff? Let's see. Add section, binary architecture, disable deterministic archives, discard all, dump section, enable deterministic archives, globalize simple, make any defined symbols, name symbol as global symbols in the output, can be specified multiple times to mark multiple symbols. Globalize symbols. Localize symbols. But I don't know if this localization globalization thing is what we are observing. I think that global or not is a flag. Maybe. I'm actually not 100% sure. Redefine symbols. Rename symbols called all too new to the output can be specified multiple times to rename multiple symbols. Remove symbol prefix. Strip all GNU. Have specific options. Add symbol. Allow broken links. Keep file symbols. Keep symbols of type STT file even if they would otherwise be stripped. Add prefix to the front of every symbol name in the output. Do you have any of this kind of stuff anywhere? No. We have set section flags. So let's see. Maybe we can try the globalize symbol stuff. Localize symbols file name. Hmm. You know what we should do? We should look at the elf file as well and see if the elf file looks like this. Like the question is, do we get this put in the first invocation or the second one? Hey, Neurosite. No, I don't have user space going yet because I'm having trouble with some linking stuff that the book wants me to do to basically bundle the like a user program in the same image as elf file as the kernel. And there's like and then I'm basically enjoying all the weird C linking behavior, like my symbols now have file paths in them. Like, what the fuck? I didn't ask you to do this. Why are you doing this? So yeah, here's how we do it. Remove the cache, Zig build verbose. Let's find where the elf file is, and let's look at it. Oh no, wait, it wasn't an M, right? Oh, it was an M. Oh, so the elf file has a ton of stuff in it. Okay. Pipe less. I'm dumb. Pipe less. Pattern not found. Stack top start. Wait, that's it? Stack top start and then a bunch of ends? Stack top. Oh, right. Right. These symbols are here and they are fine. So the answer is that no, it's not the first invocation. The first invocation that creates the elf file, that one is okay. So the elf file is okay. The problem is it's our transformation from binary to object file. So it's this invocation of object copy that does weird stuff. It's this one. It's the ibinary invocation. Yeah, still object copy weirdness. What if in Zig you put @c export for the functions? That is not something that is defined by C. That is, these symbols actually are not even symbols that correspond to function definitions. These are symbols that get created by calling object copy. Object copy creates those things. As part of its work of transforming stuff. Yeah, and here we end up with all the weirdest stuff. And I bet you that it's this one. I bet you that it's basically this path here that's causing trouble. And you know what? I think I can prove this. Let me do this. Here's what I'm gonna do. Copy this file here as shell.elf. So I have shell.elf in here. And then I'm gonna run this command. Actually, I don't need shell.elf. I need shell.bean. I'm dumb. Okay, I have shell.bin, and I'm gonna run this command here. And now it has a good name. Here's another test. Thanks, object copy, I guess. You're trying to use the kernel binary as a mini file system. This is like, yeah, basically kinda. Seems like an embed file would be more fun. Maybe. The problem with that embed file is that you don't have the same level of control of, for example, at which address that data should be loaded. Because what this is doing is then, I believe, making sure that this, what's in this object file gets put at the right address into the alpha executable. Because then everything gets loaded verbatim. And then those addresses, I think, gets used also elsewhere. I might be wrong, but I think that's how it works. Set CWD. That is a good suggestion. That's how we solve it. Do we have something to take from a lazy path? The directory name? Hopefully we do. Their name. What's going on here? As well, we have a built-in object copy step. Yeah, but it doesn't do all of this stuff. It does only some. It does. I think it does iBinary. No, wait. I don't remember. I think it does some of this stuff, but it doesn't do everything. I might be wrong though. I was looking at it earlier. It didn't seem it was able to do everything. Also, what? Look, I'm going insane over some behavior of object copy that at this point I'm fine with this. But you know what? I will be happy to see if we can upgrade later. But it's gnarly. Like some things that are happening are really gnarly. So by adding. Okay. Let's see if that works. Okay. There we go. Binary shall be in size. They now have the proper name. Looking at the next chapter of the book, you'll probably find if you use a embed file, you don't need any special alignment. Couldn't you convince that embed file to align on a page boundary somehow? Well, I think the problem is not aligned on a page boundary, right? The problem is I want the final elf file to have that data to be put in the correct order. Am I saying something dumb? So that when it gets loaded into memory, it's at this address. Or whatever the address is that we specified in the linker script. I don't think we can do that with that embed file, right? By the way, you guys might be more used to this stuff than me, so maybe I'm missing something obvious and I'm just not understanding how that works. So if that's the case, let me know. But you just don't know where the stuff goes, right? I guess it could be anywhere, and then we read it and place it in the correct location in memory. I guess. You can map it anywhere you want. Okay. You know what? Let's continue because I think we got this working. So let's continue down this path. So the previous binary is followed by the file name and then start, end, and size. These symbols that indicate the beginning and the size of the execution image, respectively. In practice, they are used as follows. This program outputs the size of shell.bin and the first byte of its contents. In other words, you can treat the binary shell bin start variable as if it contains the file contents. Yeah. And then size variable contains the file size. However, it's used in a slightly unusual way. Let's check with LVM and M again. Okay, setting aside that this number changed between here and here, but okay. The book copies the file contents anyways. Oh, does it? Wait, are you saying that this could have been an embed file all along? God fucking damn it. Then for real? Let me see. User mode. Map user pages. Okay, I'm starting to understand what you guys were saying. What you're saying is, yes, the address has to be 0x1, but that's the user space address. So the program that I compile, like shell.zig that I compile, wants to be placed there. But in any case, we do that manually ourselves. It doesn't have to be that way, right? Okay, I get it. Yeah, look at this. Fuck. Shall we get rid of all this garbage then? That means that we are good. We basically need to get to the binary version, right? We get the binary version and we're good. We don't need to do anything else to it. You know what? I'm a little bit scared. So here's what I'm going to do. I am going to... I'm going to comment this stuff out. I mean, it did get super gnarly, huh? We even had to patch the object file. That is disgusting. So I'm gonna patch this stuff out, and instead, let's go the other way around. So let's see. Let's use the Zig object copy at this point. Okay, you know what? Let's do everything with Zig at this point. Okay, const. I don't know. Bin equals add object copy. Source shell dot what is it? How do you get a lazy path to the file, to the output file? I forget. Get emitted bin, right? Thank you. So we get the emitted bin. Okay, let's see our options for this object copy. Base name format. So format, we want bin, I guess. Okay, we want so format bin. Only section pad to compress debug strip. Base name, that's like actually, what does this guy return? He return an object copy step. Okay. I'm not sure what base name does. Does it matter? So we have, okay, so in theory, we have generated the binary file, and now we need to make that available as a module, right? So we need to say shell dot add, can you do add embed file? Is that a thing? Add embed? Oh, come on. Add import? And then is there a concise way of making of taking a file and turning that into an embed? Well, into a module that I can just add embed file? I forget. I know that there is a way. I just forget how that works. Add import and module. Then how do we make an easy module? Create, add import. I guess it's probably something that comes from B, I'm guessing. bcreate module. Isn't there something more easy? Well, you know what? Let's take a look at create module. Add module, create module, options, create options. Maybe create option, root source file. Add anonymous import. Maybe that's what I was thinking about. Let's see. Yeah, I guess that's kind of it, right? And I just want to set root source file. That's it, right? No, that's actually bin, sorry. Doesn't have a get emitted bin. Uh-oh. What do we have? Create. Get output. Get output separated debug. What? I'll get output in any case. Okay. So no, wait, that's our shell. And then in kernel, wait a second. Kernel wants this. It seems that we have it. $12 bytes. That does not seem a lot. Is it realistic for our thing to be that small? What's a tool to well, can I do this? No, that doesn't say match. Is there a tool that I can use to open like a binary file as ASM? I guess I can rename it .asm. No, ASM is source files, right? It's text. A tool that basically sees that file and interprets it as basically instructions. I don't know, some kind of machine code viewer. NC viewer. XXD. Object dump dash Be binary. Would obj dump work on something like this? How can I say that this is RISC V machine code though? Which I don't have. Brew install. Oh, rather. Wait, is that with an A? How do I use it? Grey Hatter, do you have a quick invocation for me? Buy a Mac? What? Then how do you use it after you're in there? All function list. Oh, that sounds right. Yeah, that looks right. Yep. We're good. That's what is this? Load unsigned immediate. Yeah, load stuff into A0, adds an offset, puts that into the stack pointer register, and then jumps somewhere. Actually, that somewhere. Wait a second. I think we're getting something wrong in our compilation though, because shell.zig. We're missing something, right? Because this is not. Oh, you know what? Wait. Let's see if this is the problem. Yeah, it's a well true, but it's missing, right? Oh, wait, was it jumping into itself? Oh my god, wait. Okay, that might be me. Wait, AAA, PDF 8, at. Wait, was it? It was jumping into itself, right? Yeah, okay. So okay. The thing that tricked me is that it's inlining basically the main function, right? Like this is the wild true. This is not jumping to the function. This is just loop. Okay. Cool. So everything is working as intended. So we can continue with the book. That was so. I would say the takeaway here is the C approach for dealing with this stuff is to mess around with object copy a lot in order to embed some binary data in a way that really freaking sucks. In a way that at the end of the day really freaking sucks. That is my takeaway. And embed file is just, it really is the easier solution. Okay, let's continue with the book and let's make this work. So wait, application, did we do everything then at the end of the day? So they're telling us about how to use symbols. Like also, how do you use these symbols? I don't care because I have a slice to these bytes now in my language and I don't need to do this weird stuff. So I'm good. I don't care about name mangling from object copy. So we are indeed good. Yeah, our disassembly, our object dump, yeah, our disassembly of shell.alpha doesn't look the same because we're using Zig at some point. Like not everything is a C-style thing that gets exported. So, okay, we're good. Extracting the executable file. Okay. Define user base at as this value. Copy. Let's go do it. So this is in kernel.zig. Where do we do this? I guess this is related to process. I'm gonna paste it here. What do we call it? User base. Okay. Okay, user base. Then the next define symbols to use the embedded raw binary initial window. Oh, yeah, we don't have to do this. Also update create process function to start application. So user entry not yet implemented. Create process. So we're setting. So we're placing at the bottom of the stack a pointer to this function. And then mapping user pages. Why are we doing this and not going to where the other entry point is? I guess we'll do that next. Okay, I don't know. Let's follow along. I'm not sure what the intent is, but let's follow along. So we create user entry. To do. Okay. Then when we create a process, instead of, wait. Oh, we're changing the signature. Previously, we were accepting a program counter. That was the entry point. Right, we were accepting a pointer to an instruction that was going to be our entry point. Now we are changing this to something different. What is this? Pointer to image and size t. Okay, that's a slice for us. It's a slice of bytes, I bet you. I don't know. Let's call it data. I have no idea. Okay, an SP0 for now it's going to be user entry. I bet you the data we don't use yet. And then what do we do? Oh no, we do use data. Okay, for image size, page size, alloc pages, mem copy map page. Oh shit. Okay, so this is the actual loading. Okay, let's take a look more in detail. So from 0 to image size, page by page, we alloc a page. Then decide if we have a full page, I guess, or minus than that, or less than that. Let's see, handle the case where the data to be copied is smaller than the page size. Yeah. remaining is image size minus offset. And then copy size is if page size is lower than remaining, page size, otherwise remaining. Okay. So let's see, where do we do this stuff? So user entry, then map kernel pages. Here we're mapping kernel pages. And then after mapping kernel pages, we do this. So I can't cast that data as an array of pages. So I do need some kind of offset. So that's fine. So as long as offset is less than data.len, let's call it image at this point then. Okay. Okay, we keep increasing with page size. Create a page. This math is kind of sus, but fine. And then we mem copy. Destination source. Uh-oh. So destination is going to be our page address. Yes. Page address sliced from 0 to copy size. Then image sliced from offset to copy size. There you go. And then we map. So table 1 is going to be p.page table. Virtual address is going to be user base plus offset. Right. Page. Which in our case is p. And then these flags. User read, write, execute. Okay. So let's see, we modified the create process to take a pointer to the execution image and the image size as arguments. It copies the execution image page by page for the specified size and maps it to the current process page table. Also, it sets the jump destination for the first context switch to user entry. So somehow we're not trying to enter into the actual thing, but okay. Let's see, if you map the execution image directly without copying it, processes of the same application would end up sharing the same physical pages. It ruins the memory isolation. Oh, that's a key point, I guess. Let me think about it. What is the problem with isolation? The problem is that those processes will have different stacks. They will have different heaps, but they will still have memories, like pages that are writable. In our case, we're making everything writable. In theory, probably we would want to make pages that contain like machine code to not be writable. And we probably also want pages that contain mutable data to not be executable. We're not doing any of that for now. But that's the problem. The problem is that some pages would have to be writable. And those would be changes shared by different processes. That's the problem. But in theory, if we made an OS where we said, look, in my OS, yes, you have a stack, yes, you have a heap, but you don't have, but all the pages that come from the executable, like that come from loading the executable image in memory, those are always read only. In that case, then we wouldn't have to copy. Oh yeah, right. We wouldn't have to copy. We could just straight up map wherever these things are. We could just map them directly, with the caveat that we would have like alignment things to worry about. We would need alignment, and we would need padding. So like the executable data would have to be padded, just so that you don't end up with random other stuff that gets mapped. And then you need alignment, because if this guy is not page aligned, if this pointer here is not page aligned, then that's wrong. Nothing works in that case. Okay. So let's see. Lastly, modify the color of the create process function. Why don't you call it kernel main, man? Why are you going through this process? Yeah, let's modify kernel main, and let's make it create a user process. So creates a process. So this is still going to be the kernel itself. Is it not going to go through this whole thing then? I'm suspicious, because this used to be the kernel process and now it's sus. But okay. Oh, I see. It's going to go through this, but like it's not going to copy anything. Okay. Oh, man, that's cool. Okay, that's kind of almost elegant. Cursed, but elegant. So kernel main, which we do call main in our case. So processes. So this is the idle proc. Don't create process A and process B anymore. Empty slice now. And then we create one user process. How does that work? Just calls create proc. The process doesn't even keep track of it. Do I call it image? No, I call it shell. Local custom p shadows. Oh no. Which of course shadows something else. That's so annoying. Why is it called page in here? Yeah, P was really overloaded. Oh man. Okay, let's see. Expected U8 found. Expected slice found. Oh, right. Const. Is my constness. Expected type U size found slice of U8. Yeah. Missing struct field valid. Oh shit. It builds. I guess at this point we can kind of make it run. Kernel panic to do. So we're correctly scheduling our process because our process is designed to hit this to do. Oh, let's rename this to user entry reached. Yeah, so user entry reached. Okay, that's correct. Then let's try in and check with the QEMU monitor if the execution image is mapped as expected. Let's go check that out then next. Okay. Yep, we do have a bunch of read, write, execute pages. And we do have, let's see, yeah, we have this. I guess in our case, it's just one page, I believe, because it's this guy. It's only this page because our executable is super tiny. So it's like 12 bytes, right? We were looking at it earlier. So it's going to fit in one page. Why is this so big for this guy? Like this is a C moment. Let's take a look at the contents of physical address. Okay, so XP, blah, blah, blah. Oh, come on. Oh, and then it wants us to compare it. Can you not show me the... Oh, yeah. Just show me the instructions already. Yep. Add a number. Well, load an immediate, add something to it, put that into SP, jump to 0. Oh, okay. Like every single thing has a different style of showing machine code in assembly. It's driving me nuts. So this one is saying like jump at offset 0, so it's jumping on itself. Well, previously, while in the other view, like using the other tool, it was showing us jump at that address, and the address happened to be itself. So I guess one shows relative stuff, one likes to show absolute stuff. In any case, we also get a comment here that tells us what that looks like. Okay. The book embeds an ELF file while you use the row binary. Oh, is that it? Right, because we take an ELF, we turn it into the binary data, but then we make an object file out of it. And the object file is an ELF object file. So... But we link against it. I assume that some of the framing around would still go away. Weird. Yeah, but in any case, but I get it, right? It's don't linkers rewrite addresses. Linkers rewrite addresses when they're asked to. right? Linkers rewrite addresses when there's a relocation, as far as I know. So I think that this is just a different style of showing things. Like the other one was showing jump and then the address where we were going to jump. This one instead is showing jump, relative offset, and then it's telling us where it is. So I guess the question is, what is jump defined as? Is this jump like this jump has to be a relative jump, right? So like probably the machine code contains a relative jump, and the only thing is that radar, whatever it's called, was just like resolving it for us, which is the same thing that this guy is doing here, just as a comment. Like, it's just a visualization thing, I guess. In any case, yeah, we kind of got this is slightly different because here they have a jump and link to main and then a jump and link to exit. We didn't do this. By the way, that's maybe also another reason. We don't have exit really implemented. So, and we get extra inlining that they don't have. So this is all good. This is all good. So transition to user mode. It's time to transition to user mode then. And we'll be almost done. Holy shit. To run applications, we use a CPU mode called user mode, or in risky terms, U mode. It's surprisingly simple to switch to U mode. Here's how. Flag s status s pi. So attribute naked is very important. We'll see about that. Write to CSR user base into sepc. But sepc, wait, sepc did not contain a stack pointer, right? We've seen sepc in the past. Wasn't sepc something that contained an instruction address? Wait, that's maybe what user base is. Wait, I don't know why I was thinking that user base is a stack. I was thinking stack base. Yeah, user base is not a stack. User base is a, what's a user base? What's at user base? At user base is going to be the beginning of our machine code, right? But in any case, and then s status s pi. The shell code, yeah, but is it actually starting there? Like, is it the case also for us? Is it real? Oh, actually, yes. We just tested this. We absolutely 1000% just noticed that that is the case for us as well. Okay, I think I get it. So what's happening for us is that since we can just embed the machine code directly, we're good. While in their case, what's happening is that they are embedding the entire ELF file, but then the symbol that they define in the linker script points at where the machine code starts. And so that's how they don't end up copying around ELF file machinery, because they have those symbols defined in the linker script that tell exactly where the machine code starts and where the machine code ends. So they probably have more garbage going around, but then they can isolate the machine code. That though still okay. So that though is I think it's a point against the fact that the fact that they link against an ELF file. That means that's why they have multiple page. They have 2 pages loaded in memory. No, they have 2 pages loaded in memory. They are still copying only the machine code, because they have those symbols that tell them where the machine code begins and where it ends. The reason why they have 2 pages is just straight up because the C machine code is more beefy. There's more stuff in there. We have 12 bytes. They have a ton of garbage in there. That has to be the case. Okay, let's continue. In any case, so I don't remember what sepc does. Yeah, right. It's instruction pointer. So yeah, let's make this happen. What is this called? Oh, that's user entry. Wait, foreshadowing. That's user entry. Right. So we're saying create process instead of running directly the original thing has to run this, right? Because we need to execute this. We need to execute this as we actually run the user program, not when we create the process, but when we actually schedule it. Okay. Okay, what do we have in here? CSRW, SEPC. Status, and then sret. Yo, sret, my boy. Oh. Is there a comma in here? I assume so. Okay. So user bay and s status pi. S pi. Okay, let's see. To switch from S mode to U mode, it's done via the sWrite instruction. However, before changing the operation mode, it does 2 writes to CSRs. Set the program counter for when transitioning to U mode in the spec register, right? And it's always that address because different processes are going to be different. But from their perspective, the first instruction address is always going to be the one hard coded because of virtual addressing. Then what else? Set the S pi bit in the S status register. Setting this enables hardware interrupts when entering U mode, and the handler set in the STVEC register will be called. In this book, we don't use hardware interrupts, but use polling instead, so it's not necessary to set the S pi bit. However, it's better to be clear rather than silently ignoring interrupts. Okay? Try user mode. Now let's try it. That said, because shell.c just loops infinitely, we can't tell if it's working properly on the screen. Instead, let's take a look at the Q emulator. So we do info registers. We look at the program counter. We see that, right, the program counter will contain a virtual address at that point. Okay, let's do it. Yeah, look, my boy program counter. It's at A. If you remember, A is where the jump on yourself instruction was. Nice. It would be nice if there was like a immediate command to say, show me the disassembly around where the program counter is. Maybe there is. That doesn't seem to be. Info replay, no. That's unfortunate. It would be nice to say, just show me the disassembly of the program, of where we are at the program counter. But okay. In any case, blah, blah, blah. So this is good. Let's see if we can observe behavior which is specific to U mode, which is page faulting, I guess. Yeah, which is, let's try to access some chunk of memory that doesn't belong to us. What happens? Okay, we put that in shell, right? There we go. It took a while to get there. So I was thinking, wait, did we fail? But we didn't fail. We succeeded. Why did it take this long, though, to get there? Well, in any case, yep, there we go. Look at this. SCOs F. Blah blah blah. Current page table. Also, can we see the address that contains user program counter? This user program counter stuff is sus. No, why is this? Yeah, so this is basically the instruction. Step C is the instruction where we would trap with a. This is wrong. There is something sus going on. There is something sus going on. So we do get a page fault, but the sepsi value is wrong. Oh, other two line. That is so nice. It is so nice that you can do other two line. You know what? Maybe we should install shell.elf so we can look at it. It is an intermediate asset, but it's nice to have, I guess. Also, wait. Okay. So let's install shell. There we go. So this is now the version with the bad access. Store word. Add the address A0, A1. Yeah, this should fail. This should fail. Oh, kernel 334. Yeah, we put ourselves in here. That's not good. So, there's something a little bit sus going on. They have to make this volatile also. Otherwise, it doesn't work. But it is in the final machine code, I believe. At least it's in the ELF. We actually don't know if it survives past that for sure. But it seems that it does survive. I don't know. I guess I can add volatile just to make sure, but can I do, where do I put volatile? Is that here? Where are we? Yeah, we start, so escos page fault. We hadn't seen anything yet. This is the program counter. Where the heck are we, man? Oh, line 334. Okay. Our exception handler poops itself? That seems to be what's happening. I think the problem is that I have something wrong. Is the original kernel mapping is intact? I think there's some stuff that we were doing with stack pointers that is probably kind of out of whack. Yeah. This stack pointer value does not seem correct to me. Yeah, the kernel seems fine. And none of these guys have user access. I am, so here's what I'm thinking it's happening. What I'm thinking it's happening is that the page fault actually triggers right away, but there's something wrong in our exception handler, and that's causing the exception handler to kind of poop itself. That's, I think, what's happening. Oh, also, here's another thing that we haven't been doing correctly. They were saying that the naked calling convention for user entry was critical, but that does not seem to be the case. Or maybe that's what's causing trouble. I don't know. User entry has a sret and then a ret afterwards. But yeah, it doesn't matter, right? Having a ret afterwards, we just never go to it. So really, the naked calling convention doesn't really change much for us. Yeah, I think what's going on is that we trigger a page fault. That's the scos, and then the scos um and then I think that what happens is that we start looping weirdly into the exception handler, and then we just do the wrong stuff. Something goes wrong, goes out of whack. Like this stack pointer is complete garbage. Okay, yeah, just checking that the thing doesn't always return that value. Well, okay, so I'll assume that this is going fine. It's unfortunate that our exception handler is weird, but did I miss anything like that needed to be fixed into it? I think I just bungled something at some point and then never got that fixed. I think that's what's going on. And actually, one way of testing this would be, where is it? In kernel entry, instead of doing all this stuff, we could do this right away. Before the assembly. And we could print. The problem is that if we do that, the problem is that doing that before messing with the stack pointer, that could make us have a bad stack pointer, and then it would cause us to crash. If you don't take care of the stack pointer right away, we're kind of cooked. But maybe it works. Can we add panic? No, we just need to print. Sorry. What am I doing? That's close. Runtime call not allowed in naked function. Right, but then there's still the problem with print. Can we inline print? Can we inline print? What? Oh, wait, right. Not even with always inline. Come on, man. I guess it's because I'm inlining this, but not inlining everything below it or something. Okay, so this is not gonna work. This is not really gonna work. What can we do? I guess we can try to crash here before everything gets messed up more than that. We can do at breakpoint here. The problem is that it's still gonna try to, it's still gonna override stuff. Yeah. Wait, although the S code is different in this case. Okay, something is a little bit fucky. 3 is breakpoint. Yeah. Okay, that makes sense. So this still doesn't solve it. It's because this doesn't solve it because it's still trying to handle it, man. The problem is that if I turn off my exception handler, oh, you know what we could do? Wait, I'm dumb. We could just loop forever, right? Right? If we loop forever, then it doesn't change the state of anything. Yeah. We're looping there forever. Let's see if we can get some good info. Scode's page fault, so that's correct. Why is there an mcos though? There shouldn't be an mcos at this point. No? It should just be happily looping at this point. It is happily looping. Why is mcos set though? Well, the good news is that subc is pointing to where we expect it to point. Subc is pointing at our bed instruction. Well, probably, right? It's around that. It's around there. I'm not sure if 10 is exactly where that stuff is right now, but it's kind of there. Yeah, no, it's more than kind of there. It's exactly there. Okay, perfect. So we are getting a page fault from there. Then our kernel handler poops itself, as I suspected, but we actually verified that more precisely. Okay, well, you know what? The good news is that now we will, well, good news is that now that we have to implement syscalls, we're gonna really have to dive deeper into what's happening with the exception handler, because that guy has to implement syscalls now, and so all the stack shenanigans have to be done correctly. So, as I said, good news for some definition of good, but at least we'll have to face it now. Is there anything else in this section? No, that's exactly it, right? Yeah. Okay, system call. Let me see how am I doing with time. I think I have time to work on this. I'm not sure if I'm gonna finish it because if I didn't have any bug in my exception handler, maybe we would be okay. But I do have that. Worst case, you know what? I can backtrack back to kernel panic and exception and double check my work there and see if that matches. But in any case, let me think. Yeah, I think I'm good with time. You know what? I'll take a 5-minute short bathroom break, and then I'll be back to continue. So let's go get our syscalls working. Okay, I'm back. And I have some tea. Ooh. Okay, let's see. System call. In this chapter, we will implement system calls that allow applications to invoke kernel functions. Time to hello world from the userland. Invoking system call is quite similar to the SBI call implementation we've seen before. The syscall function sets the system call number in the A3 register. I guess this is entirely up to us, right? We decide how we want this shit to work. Let's see, system call number in the A3 register, and the system call arguments in A0 and A2 registers, and then executes the equal function, the equal instruction, sorry. And then the equal instruction is a special instruction used to delegate processing to the kernel. When the equal instruction is executed, an exception handler is called and control is transferred to the kernel. The return value from the kernel is set in the A0 register. But isn't this entirely up to us to decide? Right? I decide how to implement this, don't I? Let's see. The first system call we will implement is putchar, which outputs a character via system call. It takes a character as the first argument. For the second and subsequent unit arguments are set to 0. I'm guessing that the reason why they're going with just pass down one character at a time has to do with the fact that this way you pass down the data, right? And you don't pass down a pointer to a string. Because if you pass down a pointer to a string, then you need to devirtualize that address. You need to translate that virtual address into something else. User space pointer chasing is extremely complicated. So that explains probably why also the other function does one character at a time. Except on ARM, which has an instruction for it. Interesting. It almost sounds like, well, it kind of sounds like that it's not a bad idea to make an instruction for it. The kernel and user app use the same page tables. So user pointer is directly accessible by the kernel. Oh, you're right. In our case, because we have a one-to-one mapping. That is true. Okay, let's see how that works. Handle equal instruction in the kernel. Kernel.h scos equal 8. Oh, so there's always our own usual handler, but then there's a check in the case that what we're looking at is a syscall, and we see that in the scos. Scos equal 8 is what we're looking for. Okay. So even more, I don't like, so they're proposing this calling convention, and you know what? I don't like it. I'm going to make my own. I'm not going to change it much, but in any case, so we were saying, I put this stuff in here. Did I? Oh, it's in handle trap that happens. Right. Okay, handle trap. Oh, you know what? We can even say this. There you go. Handle syscall. Oh, that's something new. And then write CSR sepc user PC. Let's see whether the equal instruction was called can be determined by checking the value of scos. Besides calling the handle syscall function, we also add for the size of the equal instruction to the value of sepc. This is because sepc points to the program counter, where we got what got us here. So we want to go past that. And then we want to write it back, I guess. I see. Cool. Okay, and then we do handle syscall. Okay, handle syscall. What do we do in handle syscall? Oh, we pass down the trap frame. So finally, we have a use for this stuff. System call handler. Right. So those registers are not in the CPU anymore. Those registers were saved on the stack. And so we access them from the stack. Yep. Huh. That's cool. Okay. So let's see, handle syscall. Switch A3, and that's where we see the okay. So TF top frame. Okay, we need to decide which register we want to use then for our calling convention. So I'm gonna go with A0. So I'm gonna say A0. So F dot A0. And if it's equal to what do we say? Put char, right? Which I didn't find anywhere for now. Where do we define? So this is a define that needs to be shared between kernel and shell. So we do need something like a header file, not a header file in our case, but we finally do actually need something of that sort. So let's go make one. Common.zig, I guess. So pub const syscall is, maybe we can make it an enum. No read for dot slash. Oh. So syscall is going to be although there's not even an else branch. You know what? No else. Okay, so put char, and then in here we do, I don't know, console dot print put char. Okay, I'm not gonna actually implement it for now more because I suspect that there's some stuff that's mangled. So well, let's see if we even get here first. In any case, break unexpected syscall. That's the syscall. Oh, that's it. Okay, then now from shell, we don't do the bad pointer stuff, and instead we call the syscall, so asm volatile. So what is it? Load unsigned immediate in A0, the value. When you're supposed to write a syscall function? Yeah. I guess I can put it in here. Would be in common, I guess. Whatever, guys. Let's. I'll get there. Let me just do this first. So that and then equal, right? That's it for now. That's all we have. We don't have any more than that. Actually, I'm not sure. Do Zig enums start at 0? Oh, so it's more complicated. Wait. So what? So it's li. I didn't know that you was that. Okay, so li. Do they start at 0? Okay, so we should be good then. I Error union is ignored, right? Hello kernel, created process created, yielding, but then it doesn't print. Kernel panic, F. Okay, so we 100%, our stuff 100% goes out of whack as we try to get into the exception handler. I did specify the size. So let's double check for a moment that it is 100% our exception handler, because I mean we tested most of this earlier already, but just to double check, let's put a while loop here. scos is 8. So yes, scos is our equal, and then we are just looping. Scos is equal. What's in A0? Where's my A0? Am I dumb? Oh, A0. Well, there's a 0 in there. Okay, well, sure. That works. That we did put a 0 in there. Okay, so you went the wrong way. What do you mean? I put the register to that value. Yeah. Okay. So the problem is this. The problem is we do shenanigans with the stack pointer in here, and we do something wrong. Some of this stuff was right at some point, but sometimes it's wrong. And I think it's easy to understand where the problem is because I don't think it's an internal consistency problem. This is all internally consistent, I believe. The problem is the fact that we take our stack pointer from Scratch, and I bet you that there's garbage in Scratch. There's a 1 in Scratch. Is that right? That does not seem right, doesn't it? What's supposed to be in Scratch? In Scratch is supposed to be I think in Scratch it's supposed to be the kernel stack for a given process. Yeah, it's the kernel stack for a given process, right? I mean, we can see that in yield we write to S Scratch. It's in context switch. Well, it's in yield and then calls context switch. Right? Am I going insane? I might be going insane. It's not context switch. Wait. Oh, okay. It's in yield, but not in context switch. Okay, in yield. Next, stack. Next, stack clan. Right. So we were told to do this sus thing. By the way, doesn't that also mean that we're putting in S Scratch like a weirdly small value? Wait, was it supposed to be this? I think that was it. I don't know for sure because we're still looping forever in our exception handler, but I think that was it. Let's see. Remove the mega loop. Puchar. What do you know? Easy. Easy. Okay, we are pucharing hard. We're pucharing hard. Oh, you know what? Now we can finally, oh man, let's enjoy a nice page fault now from userland. Or not. Maybe not. Maybe something, what's going on? Stack pointer seems fine. Where's the program counter? Where the fuck are we? Wait, can I do this? Can I ask for like a specific offset? Can you just do pointer of, I don't know, can I? I was worried that by slicing past the end of everything, although this would be just an empty slice, right? So no, you're right. I can do that. Yes, I can do that. That was me being overly, not being precise with understanding that, yes, you can slice up to len that's empty. As long as you don't try to access anything in there, it's fine because its length is 0. So yeah, I think it should work. I think you're right. Where's that? Kernel. There we go. Oh, am I missing the dot dot? Yeah. Come on. Yeah, so that works. But we still are not reporting our page fault correctly. So putchar works, but if I put a page fault, we don't see the page fault. Why don't we see the page fault? Why do we not see the page fault? Esco's 2. What's 2? Oh my god, look at my stack pointer. No, wait, nah, the stack pointer is not necessarily borked. That seems maybe potentially reasonable. The stack pointer is in kernel memory. Is that okay? Yeah, 2 is a legal instruction. I want to see given an offset. Can you just give me an offset? -O for offset. Come on. Offloading and then prefix. Why are these tools like this? Range. -R for range. Alice for relock. Never mind. Basically, okay. I can do other 2 line and pass it an offset, and it tells me where it's supposed to be. Oh my fucking god! It's in IO writer. Okay, that's funny. So that's not our fault, by the way. No, wait, this might be our fault. We might have a corrupted stack pointer, and so we might trying to use something as a stack that we shouldn't use as a stack or something like that. But I guess, sorry, Jacob Lee, going back to your answer. So with other two line, you can pass an address. With object dump, you can look at the object dump, sure. But I was hoping to have something like object dump. I guess basically a shorter version of this. Pattern not found. Are you serious? 670. What? Okay, so invalid instruction trying to subtract something from the stack pointer. We have a bad stack pointer. I think that's what's going on. I guess we are basically underflowing the stack pointer. That has to be it, right? The fact that we have illegal instruction and that's what it does, we have a bad stack pointer and we're just underflowing it. That should only crash if it's not aligned. Oh, not underflow. Okay, understood. Thank you. So it's still having a bad stack pointer, but then it's, well, at the end of the day, we basically took a value that isn't the stack pointer and started using it as a stack pointer. That's kind of what's going on. I'm thinking. I'm trying to think if there's like an easy way to lesson on it. I don't know. What if we don't swap out the stack pointer when we leave the stack pointer as it was? Would that be the end of the world? It wouldn't really, would it? It wouldn't. Like, if this logic would be kind of borked. But let's say that for now we don't care. Let's say that for now we don't care. Man, the thing is, oh, there we go. No, but that's still wrong. First of all, it's taking too long to get here. And second of all, user program counter is this. That's not the user program counter. That's not the program counter of where we are triggering the invalid read. So there's still stuff going wrong in our exception handler. That's unfortunate. Nine, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. 31. Wait a second. If it's 31, why are we going from 0 to 29? We should be going from 0 to 30, should we not? If it's 31. .30sp next line. Oh, you're right. Wait, no, I'm confused still though. Because we're doing 29, then we're skipping 30, and then we're doing 31? Wait, no. Okay, wait, this is... Four times 31 minus 4 is 4 times 30. Okay. S11 and then SP. Yeah, that's a good point. You know, the thing is, I don't know how to do that with QEMU. I should probably try to learn that. In any case, we got most of the syscall stuff working. I guess at this point we could at least push and get the syscall stuff working, and then come back and try to troubleshoot what's going wrong with our thing here. So let's make the syscall stuff more serious. So syscall put char. I guess maybe we could put a courtesy function in here. So we could say like syscall dot perform send issue invoke. I'll go with invoke. Oh, there's also the return value stuff. Well, we're not worrying about that for now. Let's say that our syscalls don't return anything for now. So invoke ID is I guess that's just like this. Do these all have to be load immediates? No, wait a second. This is not immediate anymore, right? This is this has to be a move. Can you do this? Like, are we looking at like formatting syntax? Is this legitimate? You cannot do any of these. Fuck. So that's why it has to be syscall 0, syscall 1, syscall 20. God fucking damn it. Okay. Fuck it. Let's go with the other approach. You can still make any type work. Yeah, I assume that there are ways of making it work. I just don't want to get more complicated than this. I guess I could use like some kind of string formatting and comp time stuff, but it's fine at this point. That seems a little bit overboard. If I could cheat with this pre-existing syntax, then fine, but otherwise. Yeah, like 1. There we go. ID arg. Okay, so we have this. So in user, well, shell.zig, we can do syscall common.syscall. Okay. Ooh, else undefined. Oh, interesting. Could you not use an intermediate constant for the IDX? The way I'm defining this, no, because I am making this function, like you use one for put char and maybe if you're going to use it for something else like exit, for example, right? So I want you to use one also for exit. You could argue that that's maybe not a good idea, like in terms of overall design, fine. But right now I'm making, or I guess alternatively, I could make syscall a comp time argument. Alternatively, I could say that this is a comp time argument, and so thus, thanks to that being comp time, I could maybe make that work. I don't know. Maybe the Zig syntax fights me, but then it would be an immediate that can get put into the machine code, but whatever. Okay. How are we doing? Christoph, do you speak Italian? I do. Yes. Said type U32 found, yeah, something that is not a U32. What do I want arc to be a U32? I guess in this case, okay, so this is interesting. If we make this a put char, I guess char has to get widened or something. Okay, now we have exit on the other end. I'm gonna comment it out so that it doesn't complain. So we have put char. Okay. Now we need to make the kernel do something with input char. So put char. We have a 0. Wait, do we do it right? Yeah. So basically we want to do this then. Try console.print, or I guess we can do write function, write byte. Oh, it can't just be a byte though. I guess well, it can be a byte. We need to just cast it. Yeah, we were printing. Wow, allowing user space to just crush the kernel like that. What can I say? Yeah, obviously this is not the right way of doing this, right? You need to be defensive against the weird stuff that userland is gonna send you, but whatever. Okay. So what can we do? What can we do next? So I guess we now have put char, but we don't have print. We don't have userland print. So now we need to implement userland print, which, okay, so here's the clever trick that the book is using. The book is using the same exact syscall signature for both our syscall and the syscall, whatever you want to call it, that basically our BIOS offers us in QEMU. So so they can share the implementation, but we can't because we have different implementations, which I'm happy to keep separate. So in our case, we need to go into, is that going to be in common? No, that's like a user thing. You know what? For now, we're going to put this in shell. Although maybe all, you know what? I'll put it in common so that all applications can share this stuff, I guess. So I guess we can call it console. Any writer. So write function. For each byte in our string calls syscall dot one put char b. We don't even need these things. There we go. Params have RLS, so you don't need the const type annotation. Wait, you mean, where do you mean that? About write byte. Ah, okay. Oh, I see your point. Yeah, that's a good point. Yep, totally makes sense. Okay, so we have console also userland now. I guess we can also do this. Maybe we can keep console private. Then we can do pub const print, pub function print. There we go. We have our shitty debug print. So now in shell, change this. We can change this to common.print. Probably should extract print. Okay, let's see what we're doing wrong. Expected pointer, blah blah blah, found. Oh, const any opaque. Yeah, I keep forgetting that. What's the next problem? Any error use size. Wait, do I really need to say any error in here? Oh, use size. Oh my god. It's not, I guess it's not this. It's use size. Missing context. Yeah. Oh. Wait a second. Oh. This is going not well now. Because now we are... Wait, why are we... We're erroring out hard now. Wait a second. User PC 1002? What? Okay, let's get back to the original stuff that worked. So we do that does work. But a zero sprint poops itself. But user program counter is the beginning of our thing? No, wait, that makes sense. We were looking at it. Okay, wait. That makes sense. That means that store word. It means that we're having stack woes. Your start is completely wrong. Why do you say it is completely wrong? Let me think about it. It is true that this stuff should be at the top, right? Uh-oh. 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 Yeah, this should be at the top. This part. Oh no. Yeah, it got bungled. Wait. Okay. So I guess we can see this. Uh, yeah, this is the good stuff, I believe. But then this gets pushed down by other stuff. Okay, to be fair, the original implementation from the book did have us use call as an instruction and call into other symbols instead of doing what I'm doing here. Could it be that this is why? Could it be that this is why? Yeah. Wait, isn't this correct though? I have in the linker script some. I have stack top. So in my linker script, I define stack top here. So we're leaving 64 kilobytes for the stack. Wait, could it be that that is not a lot? Not correct. Um, really? Qualcomm C requires the stack to be set up before the function is called. Oh, so it feels allowed to move, but this is setting up the stack, right? This instruction here is setting up the stack. The stack. The first line of the function is incredibly too late. But why? We don't do anything. Like if I look at this assembly, it doesn't do anything. Well, okay, wait. I guess I understand your point. Your point is in this simple case, that's fine. In the complex case, it's not fine, and I see that because it's doing stuff before running my stuff. Right. What is this then? What is this code doing then? No, the li is fine. So this is the curl pit. The first instructions of every function is setting up the stack frame before any code is run. Okay, so you're saying, I think I get it. You're saying at some point it will need this stack. So, but the way the machine code generation works, that code gets placed at the very top. We immediately make space for on the stack for variables and whatever we're gonna need. So that always ends up before whatever I put in the beginning here. Okay, so I guess that's why naked was a thing in here. I think the problem is that if we make that naked, something else is going to complain. Runtime call not allowed in naked function. Okay, so I know how to do it. Export. Actually, no, I don't know how to do it. No, I do know how to do it. Okay. I know how to do it. Yeah, call shell. But wait, that is that gonna work with a Zig function? Do I not need a... Okay, I assume that I would need a C piece of glue. Okay. So, okay, that's cool. No, I was hoping. I guess my point is that I was hoping to at some point get a function that allows me to use try. So that's why I wanted at some point the Zig convention. Okay, let's see how that goes. Undefined simple A1 in shell.zig line 10. What? Where the heck am I mentioning A1 in here? Oh, is it this guy? What? I don't think it should be R. Oh, you're right. Okay. We still cannot panic though. Something else goes wrong. 14. Okay, so we AUEPC. I don't know what that instruction does. Oh wait, is this part of like jump and link relative? Wait, why is this not? Wasn't that supposed to be a call? What happened? Loads the upper bits of shell.shell into raw. Okay. Call is observed instruction. Oh. Oh, I see. Okay, so this part seems to work, but then we pooped ourselves in at 14. At 14, the stack pointer is still not good. We can't subtract 20 from, we get a page fault subtracting 20 from the stack and trying to do something. That seems weird. $20 base 16 is what? 32, right? Base 10. So it's not even that much. User stack was probably never pointing to valid memory pages. Let's see. Yes, that is wrong. That is wrong because that's kernel memory. That is not. It is that is. So I think we're getting a page fault because even though it is mapped, this is not user. This is not user memory. I think we can test this actually. Wait. By the way, I need to quickly do and have a food break, but before I leave, let me test this for a moment. Kernel, Zig. Let's not enable user mode, and I think that this will succeed. And maybe poop itself somewhere else, but we put user mode in yield, I think. Oh god, where's yield? That's the wrong SP. That's after the kernel switched to his own SP. Oh, yeah, you're right. Where can I see the stack pointer? Do I have the stack pointer of when things went wrong saved anywhere? Isn't that what S scratch is? Could be, but then if that's the case, it's still super, super wrong. Yeah, you're right. I can't look at the stack pointer. That's the currently active one. I don't remember. Was one of the info stuff useful? Where is it? Like stvol. Okay, in any case, I need to have a food break. So give me 10-15 minutes. I'm gonna have a food break, and then I'll be back. Are you still only mapping one page for the application? Because if so, then the stack is not mapped. No. I'm creating a page for the first level of the page table. Then mapping space. I think this is the kernel stuff that we're mapping here. You're only mapping the apps code. Are you saying that that's something that I forgot to do, that I wrote down to do and I forgot to do? Not mapping the stack for the app. I think, is this like something that's missing from the book? Like, is there a section where they tell me to do this and I forgot to do this? I think this goes back to the book link in the ELF. They did have more pages than I did. Oh, yeah, that is actually true, right? Because in their ELF, you're right. In their ELF stuff, they specify space for the stack. And we just don't get that with our technique. Where is it? User.ld, right? Yeah, where's this stuff? Oh man, yeah, totally. Wait. Absolutely, yes. Yeah, we totally failed this. That also means that for us, stack top is... Wait, who needs stack top? No, okay, it's fine. So basically what we need to do is like... fuck. But why isn't this output in the binary version though? When we convert these, when we convert the ELF version of our code into a bin version, why does it not have also this stuff in it? Stupid object dump. Did I delete that code? Technically, I still have it. So we could try to go this route and see what happens, but we still would need to write some glue code compared to what we have now. I guess the simplest version is to just map some extra pages afterwards. How many? I don't know. But like a bunch. So that explains why they were mapping so many pages compared to us. Oh, Jacob Lee, it's a long story. It's a long story. It's a long story. You should also ask why DD. Why are we running DD? That's another funny story. They set the alloc flag on BSS, which forces the flat binary to include the BSS section. Oh no! Oh, you're right. I get it. The problem is this. The problem is that we were doing it right with this original invocation. But then when I changed things, I forgot about this. I forgot to re-express this in our invocation of object copy. So can this be done with our object copy? Pad 2. Okay, so I really need to go eat something. So let me go eat. Please let me know how this looks like in Zig's object copy. And when I come back, then maybe everything was fine all along. Okay, I'll be right back. Uh-oh. Set section flags. Not possible on 013. It's master only. Uh-oh. Uh-oh. So we're kind of cooked, huh? We are kind of cooked, aren't we? Okay, let's comment this out for a moment then. Let's comment this in. Let's see how that goes. Hello from shell.zig. Wait, then we trap? What the heck? Why are we trapping? What did I do? What did I do? Did I forget to unfuck up this thing? No. Oh, this is fine. Wait, what am I doing in shell? Wait, what? We're just supposed to be looping. We failed to loop. Zero PC 6E. So, okay, we're done with eating dinner. What's going on, man? Oh, wait, I know what's going on. Our clubbers. We forgot the clubbers. We forgot the clubbers. We forgot to point out that we're clubbering the heck out of these things. Maybe I shouldn't be using A0 or A1. I don't know. What are they using in general in their syscall interface? What are they using? I mean, they are using A, guys. So it's on me. Use A0, not MB. Can you tell me the syntax? I'm not sure. I mean, you mean this, but then you say not MV. Oh. Oh. That makes sense because that way I'm not forcing the thing to use a specific instruction, right? Like it can choose a different instruction. Okay, then we're missing the club bars, right? So what is it? Is it memory? Technically, no. Right? We don't care. We do care about A0 and A1. Wait. No. Those are not clubbered, are they? Wait. This assembly puts stuff in there, sure. But I mean, we are using these things. So it's wrong to say that these are getting clobbered, right? You can't write it that way. Okay. But in it, Okay, I'm confused now. You can't write it that way. Where do I write it then? Yeah, the kernel system handler stores registers from the struct. That is correct. You're right. It does do that. And also registers that we write to ourselves in here, I'm assuming doesn't require us to mention them in clubbers because I mean, we're just explicitly using them. So when you said that you can't write it that way, what did you mean? Now we don't crash anymore. Yep, and we're still in userland. We're at 54, which is our beautiful loop. So this is what was making us crash. Can I see the asm for a bit? Yes, sure. Let me wait, let me actually so Zig will run. This is the version that runs and then poops itself. Wait, where's the equal stuff? Wait a second. Am I going to say, oh, don't tell me equal is another pseudo instruction? Is that it? The bug was using move to write to registers without clubbers. But without MV, you're not writing to any registers. No, it's real. Then, oh, wait. Is it in line inside? Oh, okay, it's in here. The bug was using MV to write to registers without clubbers. But without MV, you are not writing to any registers. Because you're saying those values are already somewhere in some registers. Or rather, they have to be somewhere in some registers. And so we're just making the compiler pick the ones that we want it to use for them. Okay, but continuing down this path, which I get it, it's worse. But let me do then the clubber thing. So is that A0, A1? Like this? Yeah, that's it. That's it. So that solves it. But it's not the best version. This is the best version. Okay. Success. Holy cow. We have syscalls. So now there should be the disk IO part. Oh wait, system call. Did we do all of it? We didn't do all of it. Wait, we did at least some of it. We did put char, so that's good. We do print. That's the system call. Yeah. So we got basically to this point. We got to successful hello world, which is great. Then let's see. Receive characters from keyboard. Get char. Oh shit. Our next goal is to implement shell. To do that, we need to be able to receive characters from the keyboard. SBI provides an interface to read input to the debug console. If there is no input, it returns -1. Okay. The getChar system call is implemented as follows. So you implement getChar, you call getChar. If it's greater or equal than 0, then you put it at in A0. Otherwise, you yield. You don't write to A0? Why does this not write to A0? Because A0 is already supposed to be 0, I guess, because of their calling convention. Interesting. The implementation of the getChar system call repeatedly calls the SBI until a character is input. Oh, wait. Oh, shit, no. That's why it doesn't do anything. Wait. No, because... Holy cow. Because we yield yes... But then when we return, we loop again. How does yielding in here work then? Wait a second. Wait, doesn't userland need to loop as well then? It does not. Yeah, okay, let me read what you were saying, Jacob Lee. So this is about clubbers, yeah. So even with clubbers, it was not correct. The compiler is allowed to decide to give you arg0 in A1 and arg1 in A0, and then you have a register hazard. Wait, why? Wait, why would it be allowed? Why would it allowed? Oh, I think I get. No, I don't get. I don't get it. Clubber means you write to the register. It's still allowed to give you inputs in those registers. But if I, sorry, okay, maybe you need to explain it to me like in 5. But if I do A0, I don't know, something, and then I do MV A1 something. When this happens, then this happens, and then equal happens, right? The compiler is not allowed to put any other instructions between these guys, right? So this would always work, right? There is no way for this to not work correctly. I'm saying the compiler could decide to assign ID to A1 and arg to A0. Oh, okay. I guess your point is if ID happens to have been in, if arg happened to have been in A0 and then we override it with ID, then we try to put arg in A1, but that has been overridden. So now we're basically placing ID also in A1. Is that what you're saying? Is that what you're saying could happen? Well, with this version here above. Correct. Holy fuck. Okay. I see. So like this is the syntax. Without this syntax, you're cooked basically. A register hazard is when you clubber a value in a register before you use it. Whew. Okay. I believe yield is just a jump to the return address, but saving some register before jumping into memory. Yeah, my point is though, You could make it work the other way, but not as you wrote it. I would be curious to see what the proposed syntaxes look like. I remember there at some point people like Felix had like strong opinions on how to change things, and there was a bunch of discussion. But then in the end, I think nothing really happened. Okay, let's implement getChar. Okay, getChar is one, but with return values. So let's do the return value usize. Return value is ret freak. Where does the return value go? Now it's clobber time, right? Now it's clobber time. So now, for example, I decide the return value goes in A0. Do I need to mention that in a clobber? Push on the stack, then return. So you're saying, alternatively, I could make this not expect any register to be changed. And alternatively, I could have the kernel push a value on the stack, and here a write instruction. It's not a clobber because it's a return. Okay. So this would work, right? But I'm also curious to understand this other approach. So in kernel, where are we worrying about this stuff? Put char, get char. So get char. Well, we need to do, you know what, for now, let's just always return the same character. So we can say that he returns A or something. So we do f.a0 equals A. So that's a shitty get char, basically. The problem is that this is implemented in a blocking way in here, I believe. What does comtime do with the FNT parameter of the function? It allows the compiler to at comp time, inspect the string literal, find placeholders, and use those placeholders to construct a printing function that, instead of printing the placeholders, prints the expected value at that point. Okay, so read byte void. Wait, what am I doing? Not void. U8. So we do the syscall. So one. Is it actually one in this case? In this case, it's 0 actually. Okay. Um. Uh oh. Okay, let's see. Value of type usize is ignored. Syscall 1, 4 bytes. Syscall 1. Yeah. Okay, because we changed that. Come on. Throw everything away. We don't care. Okay, to do LVM support unsupported output constraint result type A is 0. Oh, the equal sign. Oh, the equal sign, right. Um yeah. Okay, so we read A correctly. That's cool. So now let's make it more real. So get char was we said that get char is an SBI call. What's the first thing? 0. Error and value. We return error. What? Okay. Okay, so we call the thing. If it succeeds, then great. Otherwise, we yield. Let's see. However, so the implementation of the get-char system call repeatedly calls SBI until a character is found. However, simply repeating this prevents other processes from running. So we call the yield system call to yield the CPU to other processes. Strictly speaking, SBI does not read characters from keyboard, but from the serial port. It works because of the keyboard. Standard input is connected to the serial port. Okay. What yeah, so the part that I was confused about is, so what happens now then when yield tries to schedule another process? So what happens if yield tries to schedule a process that is currently stuck on this syscall? What happens then? I guess it depends on what happens when you call yield. Do you somehow take yourself off of the runnable state? Maybe that's what happens. Do we like make currable not runnable? Current not runnable? The current code, I think, will resume the same process. Hmm. Okay, so let me phrase the question differently. Could it be that by calling yield, we pick up the shell process and try to continue that? If no, then why do we never select that? If yes, then what happens at that point? The syscall is part of the shell process. I see. We read garbage. That's not good. Oh, shit. God damn it. What did they define this thing as? Oh, they use longed. A long. Oh. So that would be eye size for us? It works. Okay, so we have get char working. And then they write a shell. Do we want to write a shell? I don't know. I find it kind of boring. I mean, it's fine. Process termination, exit. Oh, this seems more interesting. So how does exit work? Need to make a syscall for it. Just in case. So syscall exit. Exit sets process to proc exited and then yields. Okay. Panic unreachable. The system call changes the process state to proc exited and call yield to give up CPU to other processes. The schedule will only schedule processes with proc runnable state, so it will never return to this process. However, the panic macro is added to cause a panic in case it does return. For simplicity, we only mark the process at proc exited, right? What we would want to do normally is to free a bunch of allocated resources, right? If you want to build the practical OS, it's necessary to free resources held by the process, such as page tables and allocated memory regions. Add the exit command to the shell. Oh, interesting. Panic kernel.c switch to idle process. Okay, so you know what? I'll do the exit stuff. I'll say that if you press Q, that's the exit. Okay, so read byte, read blah blah blah. So we print exiting, then we do common dot exit. Okay, so exit calls the one argument syscall, then in kernel. Okay, then let's actually exit. So this just changes the... Oh, with PID, okay. Wait, where do I get the PID? Current proc. Oh, right. Its status. Do we have current proc? We do. Okay. Let's state unused, runnable, exited. Okay, exited, and then we yield. Excessive one argument found 0. Yes. No field name dot exit in syscall. No. No. Oh, like this is almost success. Like what the heck is going on here? No, what did it go do to? Oh, that's the syscall ID. Freak. That's A1. Wrong register. Let's make this nicer. I don't know. 42. There we go. And then we get a kernel panic because our scheduler is instructed to resume the kernel's original main only in the case that no other process is running. So it works. Success. Success, success, success. Okay, I'm going to skip disk IO and file system because I'm not interested in those parts. But if anybody is interested, then feel free to do that at some point. Here's what I'm going to do now. I'm going to go through the outro, and then I am going to read the outro. I'm going to commit. And then after I commit, I'm going to make one last commit where we update to 0.14 maybe. Then you don't need an infinite loop in user space. Do I have one? Do I still have one? I do. Thank you. Yep. Success. Okay. Let's read the outro. Congratulations. You've completed the book, mostly. You've learned how to implement a simple OS kernel from scratch. You learned about the basic concepts of operating systems, such as booting the CPU, context switching. Well, we didn't boot much of the CPU. I think that there was a bunch of a bunch of initial configuration that happened for us automatically thanks to QEMU. But okay, context switching, totally did that. Page tables, hell yeah. User mode, totally. System calls, all day, man. Disk IO and file system, not really. Sorry, skip that part. Although it's less than 1,000 lines, it must have been quite challenging at times, but it was mostly kind of a good journey. This is because you build the core of the core of the core of the kernel. For those who are not satisfied yet and want to continue with something, here's next steps. In this book, we implemented the basic features of a kernel. However, there are still many features that can be implemented. For example, it would be interesting to implement the following features: a proper memory allocator that allows freeing memory, interrupt handling, do not busy wait for disk IO, a full-fledged file system. Implementing ext2 would be a good start. Network communication, TCP/IP. It's not hard to implement UDP. TCP is somewhat advanced. virt.io net is very similar to virt.io BLK. I'm guessing BLK is the file system stuff that you get from QEMU, and they're saying that the network stuff is similar, like the network firmware thingies. Read other OS implementations. The most recommended next step is to read the implementation of existing OSs. Comparing your implementation with others and learning how others implemented is very educational. My favorite is RISC-V version of XV6. This is a Unix-like OS for educational purposes, and it comes with an explanatory book in English. It is recommended for those who want to learn about using specific features like fork. Oof. Another one of my projects, Starina, a microkernel-based OS written in Rust. This is still very experimental, but would be interesting for those who want to learn about microkernel architecture and how Rust shines in OS development. Feedbacks are very welcome. Nice. So this was a pretty good adventure, I would say. Pretty good adventure. Morning. Hello, Greaser. Thanks for finding this guide. I've started having it a go at it myself, and I'm kinda dreading getting paging working. It wasn't all that bad. There was some funky shift math that you have to sit down and think through a little bit because it's weird. That's most of it. Also, fun fact, on RISC-V, when the thing first boots up, A0 equals heart ID, hardware thread ID. A1 equals a pointer to a flattened device tree. If you use the .c_conv, then these are the first two arguments in that order. Interesting. That's cool. Right, so that allows basically the kernel to pick up some information about the system and know about hardware. I mean, I was about to say that's kind of how it has to be. Not necessarily how it has to be, but it makes sense for it to work that way. Cool. Thank you for sharing that info. I really didn't dive any deeper in terms of what the bootloader does. Okay, that was great. So let's make a commit. Oh, I should probably update also the README maybe. Fuck the YouTube link. I forgot to update this. Hey, thank you, Jericho. Have a nice evening. Okay. Let's see. An alternative is to load the static elf for the user mode binary. It's almost straightforward if you load directly at a given address. I guess the problem in our case is that we don't know exactly which elf features we will end up depending on, right? If we compare it with Zig. So we might happen that we write some code and then that ends up leveraging some. I might be wrong, by the way. I don't know exactly. I don't remember. Probably never really knew exactly what it is that elf offers precisely. But my worry is that, like, for example, let's say that at some point you have some time meta programming that requires relocations. And so now you have relocations in your elf and you're kind of screwed, right? So, I mean, of course, if you plan to get to that level of seriousness, that seems fine. But I'm happy to stop here, basically. Okay, let's update to Zig 014. Now, Zig 1 version. What do I have here? I do have a version of Zig 014. Let's start with the question. Zig 1 build? Do we Zig 1 build? Static binaries do not have relocations. Oh. Let's see. Expected point in type found fun. Okay. Okay, where is that? In shell. Okay. So everything works with Zig pretty much right away with Zig 014. Let's update the build system. Okay, people told me about it earlier. Set the section flags. F2 row or hex copying does not support set section flags. Copy to another elf first. What? Are you serious? That seems janky. Wait, does that even work? Wouldn't that still have the same problem afterwards? You need to set the flags in the elf before creating the flat binary. Hey, path. Thank you for the $25 to the Software Foundation. Thank you very much. Are set the flags in the linker script? So you're saying, is that in user.ld that I can set those flags? Okay, probably you know the syntax, but let's see if I can find on my own. What were those flags? Oh shit, I deleted them. Oh, that's not good. Oh, but I have them here. Alloc contents. Flags, flags. Flags, flags. Alloc space not found. Contents. You know who knows? Maybe good old Claude knows. Contents alloc. Okay. Wait, is that before the colon? With parentheses, right? There's a comma according to this guy. There is no way that ChatGPT doesn't know. Claude lied. Yeah, I've been calling it also ChatGPT. That's disrespectful. It fucking lied about syntax. Okay. That is no, there is no, not good. ChatGPT, let's go. Expected space but got C. Why are these guys only lying? Why are they always lying, man? What about A? At least we get A. Can we still have A? Symbol not found A. Uppercase A. I guess it just doesn't go here or something, but it does seem to have space for something. Okay. Does anybody know what I should actually be putting there instead of having LLMs lie to me? Although, I'm... type equals sht prog bits. After .bss. But, so you're saying this? Like this? That's weird. What does that even mean? Section that mismatch for BSS. No, the internal BSS, SHT no bits. Output section BSS, SHT prog bits. Shitty program bits. Oh, I see. We are making a lot of progress. I would say that the truth is that 0.14 doesn't have a gigapowerful implementation of object copy, does it? So, but Jacob Lee, you were saying that we can run this twice and it's gonna work. Is that it? What do we call this? Flagged alf. Is this really it? Object copy generated failure. Set section flags. VSS alloc contents. Oh no, extra comma. Bugs. Well, I don't have the latest version of Zig 0.14 though. Maybe updating will improve things. Okay, let's see how that goes. If this goes nowhere, then I think I'm gonna kind of stop. Changing the output section from .vss to .data should work. To .data, but was that it? Okay. Move the contents of VSS into data, nothing else. Like this? Nothing else. Do I keep this or do I take this out? Or do I move it somewhere else? Type equals shitty programming bits. No type, okay. Well, wait, technically at this point, so this doesn't work. So this needs to be taken out, right? So at this point, I don't need this, right? Which probably means that I can just straight up use Zig. No. Oh, now I have the start. Okay. It works, but it also kind of doesn't work. Interesting. Something broke. Well, in the meantime, I'm building a new version of Zig 014. By the way, we're trying something like I was trying right now just a weird combination of things. We want to try this stuff with 014. We don't care about trying this stuff with 013, I believe. Hey, Drainard, thank you for the $15 to the ZSF. Thank you very much. Drainard. Let's go. We're getting close, hopefully. Maybe in the meantime, you know what, we can do the thing where we read Hacker News or something. Let's see. What news are there? People still mad about TikTok. Using your Apple device as an access card in unsupported systems. The surprising struggle to get a Unix epoch time from a UTC string in C or C++. Robotics and ROS 2 essentials. Wait, what is this? What is this over thing? Is that some kind of AI recap that my browser is coming up with? Jesus. The Fuzzing book. Oh, that seems interesting. Lexical fuzzing, syntactic fuzzing, semantic fuzzing, domain-specific fuzzing, managing fuzzing. Okay, interesting. Set section flags crashes on master. Let's go. Let's go. Man, this is going to be the longest LVM object I think that we're going to have to wait for. Holy shit. Why are there screenshots, like low quality screenshots? Because they're from here. Let's see what Hacker News has to say. I was just reading about these wacky Germans yesterday after investigating a particularly undescriptive PKG in Pac-Man. It was the tool framework concept that these guys used in the mid-late 90s to fuzz those 2K plus bugs out of Netscape Navigator, like they mentioned in the article. Rather ingenious. Okay. I sent some fuzzing compilers and actually finding issues. Also shared under work where we have done using black box pen testing security techniques, including fuzzing in Fireblocks. What the heck is Coin Fabric? Blockchain company. Uh-huh. Uh-huh. Are we good? We're not good yet. Yeah, there isn't much interesting on Hacker News today, huh? Let's see this one. So how hard could it be? Input, we have something like this. We like to turn this into this number. The notional but not actual number of seconds have passed since blah, blah, blah. Having to figure this out led me to discover many surprise features and otherwise unexpected behavior in POSIX time handling functions as implemented in various C libraries and languages built on them. There are many good things in the world of C and Unix, but time handling is not one of them. There is a narrow path of useful behavior, however. But first, some context. The long story short is, as long as you never call setLocale, you can use strp time to parse a UTC time string. Do not use Z or Z. Pass the struct TM calculated by strp time to the pre-standard function time gm mkgm time on Windows to get the correct Unix epoch timestamp for UTC time string. Do read on the solutions for if you do use locales. C++ has better support, which could also help you from C. Points in time, positive concept of time. Oh my god. Yeah, no, I'm not ready to read this much about time. Not today. Not after implementing all this stuff in AOS. Zico review, I have some code I'd like to get roasted on. If it's something not too complicated, I can take a look. Sure. Like, I can give you an extremely superficial review if you want. I don't have the brain power to go deep into anything, though. Man, this LVM emit object thing. Holy cow. C++ 20 and some luxury. Source 3 verse MQDT. Still going. Okay, what's source 3? Source code sharing without breaking the back button using a reverse proxy is the preferred method. There's simple config in Nginx. Contrib in nginx.conf. Okay, so this is like a website. This is a website that, well, it creates like a static website, I guess, for a repository. Let's see your dependencies. You depend on verse. I see. So your other project is a dependency. Okay, let's take a look at verse then. If that's your dependency copy. Let's see what's in your zone. Nothing, no dependencies. Let's see. A comfortable and powerful web framework where your Zig code looks like Zig. Page index HTML. Where's main? Main. Server init default allocator. What's default allocator? Where's default allocator? Oh, I guess that's like pseudocode in a sense. You don't define it. Roots. What's roots? An array of matches. Well, a slice of matches. Get index HTML index. Okay. Mode Z WSGI. Okay. Serve catch errors. Which error? Server error. And then you crash. Cool. Index frame. You take in a frame. Prints a string. Well, formats a string, I should say. Index HTML.init. Index HTML.init. Ooh. Templating. Oh my god, my mouse is going crazy. Oh my god, we're getting there. It's happening. We're getting Zig. Holy cow. Habemus Zig. Okay, I'll take a quick look at how your templating stuff works. I'm curious. So page, huh? I guess it's in template. Page. Page runtime. Validate directive. You have variables split for each with. Huh. Interesting. I have some interesting news for you, Grey Hatter. By the way, I think that trying your hand at this stuff is cool. And I'm going to make a comment just to let you know some things that I discovered myself the hard way. You decide if that should inform your design or not, meaning I'm going to tell you something. You can, I think it would be totally legitimate for you to ignore that and do your own thing no matter what. But just so you know, no. The training slash does not make this valid HTML. Self-closing tags do not exist in HTML. You can have the correct way of doing this would be simple variable opens and then simple variable closes, right? So you have a closing tag that has / simple variable. That is the only way to do that correctly with HTML, which sucks. This syntax that you're using here, this is either XML or XHTML syntax. So XHTML supports this, but normally the doc type says HTML. So you don't have, this is wrong. Browsers are actually, well, you don't have to worry about browsers, right? Because this is a template that is not gonna be rendered verbatim in the browser, I'm guessing. So you have to worry about this less. But just so you know, browsers are even instructed to ignore the training slash and to consider the element still open. So if this reaches a browser, again, this is not designed to reach a browser because it's a templating language. But let's say for a moment that it was, then this would basically mean that, well, in your case, it's everything here, it's wrapped inside a paragraph. So there would be some other fallback stuff that happens. But generally speaking, a tag that self-closes is still open for the browser. If you write HTML where you have a tag that self-closes, what's next? It's actually inside that tag, according to the browser. So it really sucks. HTML is not really lenient when it comes to this stuff. Well, not lenient, but like it's, I don't know, bad design or something. That said, this shouldn't necessarily stop you. Let's see, because of other edge cases, browsers are required to enforce, so that's a works that makes parsing in verse much easier. Yeah. They ignore self-closing? No, I promise you, they all do. They totally 100% all do that. I can guarantee you. It's just that, for example, here you are self-closing, but then you are closing the parent tag. And so by closing the parent tag, you are implicitly closing this. But what's closing this? It's the closing P, not the self-closing. So if you put more stuff before you close the paragraph, you will find it's actually inside. Let's say that the unfortunate part is that, setting aside what browsers do specifically, the unfortunate part is that you will find that some HTML tooling will not play well with your stuff because you are not, the tooling might or might not play well with your templates because, again, you're kind of bending the rules a little bit. But as I said, I feel it's an interesting piece of trivia, but shouldn't be something necessarily that you should do something about. Like you can decide later on. Okay, let's see. Uh-oh, there's a fix in object copy, huh? So 0.14 doesn't have this working yet. So let's see, build.zig. So you were saying that this stuff borks. Okay, so it still has this limitation, and then we would still have to do the double step. That's kind of disappointing. So you know what? Maybe I'm gonna revisit this once these things have improved and there's actually a real improvement that we can make. As things stand, it's still a little bit too hacky. Like if we have to run it twice, it seems kind of, I don't know, shitty to me. I don't know. Maybe I'm complaining for no reason. But in any case, it's fine. Well, that was it. I think it's finally time for me to end the stream. Linker script change is just better. But, well, so when I did the linker script change, though, it did cause things to bork out, right? Because we did this. Oh, now we have other issues. Comtime int is not indexable and not a range. How was that even working ever? What is going on? How was this working ever? This kind of unbounded quantity. Oh, what am I doing? So yeah, making this change causes us to poop out. Some things don't work anymore when we do this. I'm currently learning front-end web dev on Free Code Camp. Why they teach you the self-closing tag if it's not wrong? Only code. Most people don't know precisely what HTML is. They have a generally vague idea. I myself had a generally vague idea for the longest time. Then I wrote this. Then I implemented this. I implemented a HTML language server because I wrote my own templating language for my static site generator, Zine, the one linked here at top. And so as part of that process, I actually had to go and I wrote an HTML parser myself from scratch. And that's what taught me exactly what the language spec is for HTML. The answer is that most people don't know what the spec is. They have a general idea of how that works. There's also the problem that HTML and XHTML are very similar because it's basically the same document. You just change the signature here at the top, right? Here where you say doc type. If you say XHTML plus some other stuff, for XHTML, you have to put like a different incantation. But if you do that, then suddenly self-closing tags are a thing. I'll tell you another thing that causes more confusion to happen. JSX. Whenever you write JSX, or you're writing a templating language for a front-end framework, one that like if you have, actually, you know what? I might say something wrong. I'm not sure about other frameworks that aren't like React, but for React, when you write JSX, self-closing tags are a thing, but that's because it looks like HTML, but it's not HTML, right? It's special syntax made to look like HTML that gets embedded inside JavaScript or TypeScript. So that thing does support self-closing tags. In that context, it does have meaning. It's just that pure HTML, in pure HTML, does not. HTML5 at the very least, like the modern HTML. Older HTML might have had weirder rules about all this stuff. By the way, if you want to see this in action, you can go to, like if you're using VS Code, you can go to the VS Code marketplace and install it. So it's called Super HTML if you want to try it out. So yeah, I also gave a talk at a conference, but I think they haven't published it yet. So it's weird. Let me think if there was anything else left to say. Yeah, JSX, XHTML. People just don't care much about the details. Let me see if I can show you just a quick example. I'm slightly curious to show it myself. So A checks test.html main what am I doing? HTML doc type HTML body, and then in body we do we open a div that we self-close. By the way, I have Super HTML running, so that's why it's complaining. And then I do h1 hello. Okay, I'm gonna write it like this. I inspect body div h1 hello. Are you talking, Cozy White Bear? Are you talking about the lightning talk that I gave at Systems Distributed? That one is available, yes. But then I gave a bigger talk at SquiggleConf. So check this out. You're seeing here in action. H1 is inside the div. Yeah, and it's not because H1 cannot exist outside of a div. It totally can. It's just like it will not get put in a div artificially if there's no div. It's just that it was inside that div because self-closing isn't closing. Well, you know what? Here's what I will leave you all with. I leave you all with the first HTML LSP that reports syntax errors. Since everybody is talking about this stuff, everybody seems invested. I'll send you this. Okay, this is it for me. I think. Let's see if anybody else is streaming right now. I don't see other streams. So let me see. In our nice section. Yeah, I think there is nobody else doing Zig. So since there is nobody else doing Zig, I think I'm gonna stop here then and not rate anybody. So everybody have a good day, and I'll see you next time. Bye bye.